A pleasant good morning all, and good afternoon and good evening to those of you joining us from across the globe. We would like to welcome you back to MTCC Caribbean's Caribbean Maritime Climate Action Energy Efficiency Conference and Exhibition, or CONFEX for short, because that is a mouthful. So for those of you who would have joined us in the past 2 days, we thank you for making this conference a productive, insightful, and informative one. And we look forward to the exact same thing today. So before we begin, we'd like to cover a couple ground rules. First and most importantly, we please ask that you remain muted whenever you are not speaking. This is especially important for the presenter so as not to interrupt their flow when they are delivering their presentations. If you have a question, we ask that you use the raise hand function under the reactions tab in Zoom, and the moderator will allow you an opportunity to speak. Please note, however, that we'll be taking all questions for presentations within the panel discussion session of the conference. So we ask that you either hold the questions for after if you'd like to ask them verbally, or please type them in the chat and they'll be answered by our team or in the panel discussion. We also ask that you keep your cameras on wherever possible, as this allows the presenters to feel more inclusive and it makes for a more relaxed, collaborative environment. So without further ado, let's kick off today's proceedings. I hand you over to our moderator, Ms. Sarita Mahaber.
Good morning, good afternoon, good evening again to everyone. And thank you for joining us for our day 3 of our Climate Action and Conference and Exhibition. I would like to also remind you all that our exhibition hall is open and you can visit at any time today. So today's session, we are going to have case studies in decarbonization of maritime shipping. And we have a panel of very interesting persons lined up to speak to you. And, you know, I know that you are going to be very interested to hear what they have to say. We like to say that these are technology providers and experts. And so I'd like to start introducing them so that we can get directly into that. I know you all may be as excited as we are about it. So we have first presenting Ms. Marcia Maynard. She's the Manager of Investment Facilitation with the National Energy Corporation of Trinidad and Tobago. And she's going to look at decarbonization from NEC's perspective. Ms. Maynard, as I said, is Manager of Investment Facilitation at NEC. And NEC is a 100% owned subsidiary of the National Gas Company of Trinidad and Tobago. She has a BSc degree in Chemical and Process Engineering and an MSc degree in Engineering Management from the University of the West Indies. She's a chartered professional accountant and currently serves as the chair of the Member Advisory Council for the Trinidad and Tobago CPA chapter. She's also a project management professional and serves as a member of the Project Management Institute and as a senior member of the American Institute of Chemical Engineers. She's a member of the Women in Renewable Energy Network, an initiative of the Clinton Foundation. She has worked for most of her career in both the downstream energy and financial services industries. Welcome, Marcia.
Okay, thank you. Okay, right. Presentation. Okay, so I take it everyone can see my screen?
Yes, you can see you and hear you.
Okay, great. Okay, so good morning, everyone, and thank you again to the organizers for this opportunity. I'm going to start with the usual disclaimer, which really is in respect to the information that is going to follow throughout this presentation. So this morning's presentation is going to cover an insight into national energy, a bit in terms of our areas of focus and our actions towards supporting cleaner marine fuels. So let's talk a little bit about national energy. So the NGC group of companies, it consists of 4 major organizations. We have the NGC, which is the sole purchaser, transporter, and seller of natural gas in Trinidad and Tobago's energy sector. We have Phoenix Park Gas Processors Limited, they are involved in natural gas processing, NGL aggregation, fractionating, and marketing. We, of course, have National Energy, responsible for the development of new energy-based industries and the operation of marine assets to facilitate gas-based activities. And then we have the NGC CNG, which is responsible for expanding the use of CNG as an alternative transportation fuel in Trinidad and Tobago. So this slide sort of summarizes National Energy as an organization. It is really structured in three main divisions. We have the Sustainable Energy Development Division, Port and Estate Management Division, and Corporate Services and Business Development. The vision for the organization is to be recognized as a global leader in the development of sustainable energy-related businesses. So let's talk about the areas of focus for National Energy. So National Energy is currently advancing a suite of initiatives in the clean energy space as part of the NGC Group strategy to advance its sustainability agenda. Now, I'm not going to go through each particular area. What I will do, because of our topic this morning, I'm just going to touch a bit on our work in the alternative marine solutions. So National Energy, in 2020, National Energy, through an engagement with Advision, which is part of the Worley Group, we explored looking at alternative bunker fuel supply and infrastructure within Latin America and the Caribbean. And we recognized that there are ready business opportunities as we embark on a journey towards decarbonization of the maritime sector. So this slide sort of demonstrates how National Energy offers an integrated platform of marine services, including tugboat services from three strategically located areas. We have the Port of Galeota, the Port of Brighton Atterbury, and the Port of Point Lisas. And in 2019, National Energy Guyana was also established to market the services of the NGC Group. So we're going to talk a little bit more in terms of our journey towards cleaner marine fuels. So it is our view that LNG will continue to play an increasingly central role over the near to medium term, as countries, of course, continue to adjust their energy mix to improve their economics and pursue their environmental targets. So we see the participation, in fact, from other countries to supply LNG volumes via ISO containers or via traditional larger cargoes as really avenues to improve regional energy security, which would allow for better pricing, more secure supplies, and contribute to the economic viability and resiliency within the Caribbean. We see that there's an important role for collaboration over competition, as we feel that this is really in the best interest of the region. So in terms of, with regards to NGC, we recognize the importance of both utilization of large scale and micro LNG to the regional mix. In fact, we are currently exploring supplying micro LNG to selected islands. So as part of our work with Advision, and when we looked at all the alternative fuels, we found that LNG is in fact is the preferred market-ready solution to really immediately address the IMO regulations. So from a Trinidad and Tobago perspective, with LNG, we do, of course, recognize we have existing production at Point Lisas, at Atlantic, in Point Fortin, but we don't have small scale infrastructure developed. What we have found is that, of course, there has been, globally, there has been wide scale adaptation, and we feel that, that there is, in fact, opportunity here for ready adoption of, for LNG. In the area of methanol, again, from a Trinidad viewpoint, we do, in fact, have existing production, but we do not have specific bunkering facilities. Globally, you have had adoption in terms of tankers transporting methanol and using methanol on the world scale. In fact, for the producers at Point Lisas, we do in fact receive calls from methanol tankers coming into the Point Lisas area. And in fact, those tankers at the moment, they do currently utilize methanol as their fuel of choice, right? In terms of, as what we see in terms of the adoption, we recognize that there are in fact opportunities here for adoption, but it requires IGF ratification for widespread or further applicability for other types of vessels. In the sphere of ammonia, again, existing production, as you move further along in terms of non-carbon fuels, of course, ammonia, we see it playing a role there. However, it does have a disadvantage because of the fact that it is highly toxic when compared to the other alternatives. And we believe that there's likely to be probably maybe some adoption, but maybe further out, maybe to 2030. Hydrogen. So in terms of hydrogen production, we do have, currently we have studies underway, and we will get to that later on in the presentation. However, but we do in fact produce hydrogen, but we produce hydrogen at present through steam methane reforming, because it is utilized as part of that process with the current processes to produce methanol and ammonia. So for us, in terms of if we were to look at adoption of hydrogen as part of a non-carbon fuel, we see it wider adoption later on out to 2030, even out to 2050. Although you do have small applications of it taking place in specific ports, specifically like out in Europe and so on, in terms of like ferries and so on, utilizing on smaller scales, looking at the opportunities for use of hydrogen. So in terms of in the area of traditional fuels, we see that there are annual volume sales circa 700,000 tons, servicing over 3,500 vessels annually. Our main suppliers in this traditional space are Ventron and NP. And in the area of alternative fuels, in the local scenario, as I would have already discussed, we do in fact have sources in Trinidad and Tobago in the form of LNG, methanol, as well as ammonia. And what we have found is that with the capacity additions taking place in North America because of the availability and competitive pricing of natural gas, there is in fact an opportunity that we recognize that for producers, the current producers in fact, to look at opportunities of supply on the local market. So in terms of the future and looking outward, we do in fact have LNG bunkering feasibility work that is currently underway in order for us to be able to examine and really look at leveraging the benefits of significant alternative fuel resources. So let's have a look at the supply profile. In terms of customer access, we are looking at small neighboring islands, looking at the needs of the customers, which of course will include low sulfur fuels and LNG for power in some jurisdictions. And as well in terms of looking at differentiation, looking at the Trinidad and Tobago, which of course has a current production capacity for the alternative fuels. So for LNG, we currently have 15 million tons per annum at Point Fortin, methanol about 7 million tons per annum at Point Lisas, and ammonia about 5 million tons per annum also being produced at Point Lisas. So we're going to talk a little bit about hydrogen and getting into this non-carbon space. So national energy, we see that there's significant potential for the NGC really to leverage its current network and its asset base to really explore looking at large-scale hydrogen facilities. We believe that having NGC as a major provider of clean feedstock, it is in fact going to be quite beneficial to the industry's longer-term survival. So on this slide, if you look at, you see, if you have like, for example, a larger scale hydrogen hub, you do in fact see in terms of some of the off-takers from that hub, opportunities there both for the maritime industry. There are opportunities again coming off there for the maritime industry, aviation and other types of industry. So as we progressed in terms of looking at and exploring this opportunity, on December 2nd in 2020, the IDB approved a non-reimbursable technical cooperation for the promotion of the green hydrogen market in Latin America and the Caribbean. National Energy is in fact going to be the focal agency for this technical cooperation. And we will be working in conjunction with the Ministry of Energy and Energy Industries to really explore looking at hydrogen development and its applicability in the wider Trinidad and Tobago landscape. In addition, in earlier part of this month, the NGC, National Energy, as well as Kenneth J. Green, we would have signed a memorandum of understanding to really work together to create a sustainable hydrogen economy. What we look at, we foresee that the MOU is in fact going to drive commitment to help transition Trinidad and Tobago's natural gas-based industries. For the NGC, we consider this MOU a significant step forward in our efforts as a country to really respond to the global climate change crisis. And as a pivotal player in the local natural gas energy business, it is therefore important for the NGC to demonstrate leadership, and we intend on taking that lead in being able to build awareness, as well as to support the transition to respond to the lower carbon challenges. So as we move through 2021, we see in terms of the NGC group's focus, we are looking at developing micro LNG supply and delivery to support the Caribbean region and of course, local bunkering opportunities. Secondly, in terms of assessing safe and efficient bunkering of alternative lower carbon as well as zero carbon fuels. And as I would have alluded previously, in terms of looking at assessing the operations for the NGC group's role to really participate in an upcoming local hydrogen industry. So with that, I do thank you very much for your attention this morning. Thank you.
Thank you very much, Marcia. I think that, it gave us it was nice to see, the amount of thought that you all had put into it and some of the initiatives that you all had, especially in terms of the micro solutions that you're providing to the islands as well. So thank you very much for your insights. I'd like to introduce our next speaker, Mr. Alex Gomez. And Mr. Alex Gomez is the CEO of Trinidad Energy. He's going to present to us today on the fuel provider's perspective, current and future plans for decarbonization.
Yes, good morning, everyone.
Hi, Alex. So just going to read out your bio as well while you load up your screen.
Yeah.
So as I said, Mr. Gomez is the founder and current CEO of Trinidad Energy. He leads the company's executive team and is responsible for all aspects of the company's vision, strategy, operations, and technological development as they excel in the field of international renewable fuel development and production. Over a 15-year professional career, Alex has held several senior leadership roles and has extensive experience working in the petrochemical industry. His experience in the field extends to petrochemical process engineering, diesel mechanics, renewable energy, international trading, business development, and marketing with a focus in developing new sustainable technologies from concept to full commercial production. So Mr. Gomez and Trillian has been a partner of the MTCC for our conferences and workshops for a very long time. So thank you very much, Alex, for always being willing to present for us and give our participants the benefit of your extensive knowledge. Alex, over to you.
Thank you very much, and good morning. I'm trying to upload the presentation here.
Okay.
And
would you like me to load it up on my end and change the slides for you?
Yes, please.
Okay.
So while that is happening, I am seeing some questions on the chat. Just to remind you all that we will be taking notes of them for the panel discussion.
Okay.
Just confirm that y'all can see the presentation.
Yes. Okay, good morning, everyone. Thank you very much. My name is Alex Gomez, founder and CEO of Trillion. Trillion is based in Houston, Texas. We are a developer and producer of green fuel technologies. Primarily, we developed and bring into market a product called hydrodiesel fuel, which is a water and fuel emulsion. And we've been working on this project for about 5 years. We saw how the market was trending to green products, climate change, pollution, and then alternative fuels will have to come into play. So in our development, we always keep in mind all of these scenarios coming in the near future. Next slide, please. Can you change the next slide? Hello? Oh, there you go. Yeah, so as we know, the other slide, please.
Would you like the previous
Kevin,
slide?
can you hear me? Yes, please.
Okay.
Yeah, so as we know, it's a lot of restrictions, a lot of more standards coming into play. Governments are putting sanctions. A lot of governments are putting restrictions to private companies to make a change and put standards into their operations to reduce greenhouse gases. And then what the market is looking for? Well, the market is looking for clean combustion fuels, a fuel that is economical, a fuel that is not going to harm a government's culture or economics overall. So that's what we bringing into the market. So we're really excited about that. Next slide, please. So as we progress into, hello, Tevin, can you hear me? Oh, there you go. So as we progress into the next 20, 30 years, there's going to be an increase in fuel consumption and diesel fuel and HFO. We're going to be seeing LNG as well. And then what solutions do we have from here to 2050 or from here to 2040? How are we going to decarbonize? How we are going to reduce pollution during this transition period? And that's where hydrodiesel comes in as an immediate solution, scalable, small footprint, economical. And basically all we're doing here is converting a fuel that is already in the market, converting that into a hydrofuel, hydrodiesel that can reduce emissions up to 90%, which we're going to go over that here shortly. Next slide, please. So there's going to be a lot of, here you can see, depending on the types of vessels, there's going to be a lot of diesel fuel, LNG. We're also going to be a transition to biofuels. Okay, as it comes to the market, we're going to be seeing electrofuels, which is conversion of CO2 into fuels, ammonia as well. And the good thing about hydrodiesel is that we can use these alternative fuels and convert those into hydrodiesel as well. So for example, we can use number 2 diesel fuel, we can use biodiesel, synthetic diesel, renewable diesel, we can use MGO, and electrofuels as well. So the electrofuel, once it's made, we convert that into hydrodiesel. We can expand the capacity of that fuel by up to 25%, and now we can enhance even further those type of fuels as they come into the market. Next slide, please. Hydrodiesel and enhancing clean combustion fuel. Next slide, please. So hydrodiesel water fuel emulsion has 0% free water content. It does have water infused within the oil, which we're going to see a slide here shortly, but it also has 0 conductivity. So no risk of fire in the event of a spark or static. Okay, we are a ASTM D975 compliant fuel, also the F-76 naval fuel as well. Our shelf life exceeds 160 days. We're going to be expanding that to a year to 2 years here soon with our product called HYDRODIESEL Plus, which is a non-emulsion. And at the same time, HYDRODIESEL will increase power, torque, reduce maintenance by up to 20%, and it will be the same price as regular diesel fuel or regular base fuel. And then we also have some other fuels that we're going to be bringing to the market, you know, hydro bunker and hydro patrol, hydrojet that we're developing at the moment. Next slide, please. So green fuel reduces emissions up to 90%, depending on which greenhouse gas. So we have CO2 up to 40%, NOx up to 80%, particulate matter 2.5 and 10 up to 75%, opacity up to 90%. And once we convert the base fuel into hydrodiesel, we're reducing the sulfur quite significantly. So for example, here at the Gulf Coast, ultra low sulfur diesel at 15 ppms, once we convert it into hydrodiesel, it becomes 3 ppms. So once we bring that into the marine fuels, when you're talking about the MORPU 2020 and the refineries that have, you know, strains to, and they have to, you know, invest lots of money in infrastructure to reduce the sulfur to comply with MORPU 2020, where our methodology, our product can definitely help those refiners, those fuel makers to reduce the sulfur by just switching. So just a quick implementation of our smart blending systems, and they would achieve up to 300% reduction in sulfur content. Higher lubricity, increased brake thermal efficiency, intermixing back and forth with no adverse effects, meaning that you can use existing infrastructure when it comes to piping, tanks, logistics methods. Hydrodiesel fuel is a fill and go solution. Next slide, please. So now that we decarbonizing the engine by reducing the soot or up to 90%, now we have a clean enhanced combustion with the help of the water infused inside of the oil droplet. Now we reducing the NOx because we're cooling down the combustion chamber. Okay, and now we don't have that soot walking its way down to the oil pan. Now your engine oil will last longer. You will have better lubricity. It will be less wear and tear. The engine will run smoother, and it will last longer. Lower toxicity fuel. We have a class 9 UN 3082. Meaning that it's safer to handle, to transport, and in the event of a spillage, it will be less harmful for the environment in terms of bodies of water or bodies of land. Okay, and then it'll be safer to handle because we have a flash point of 61 degrees C. Okay, next slide, please. Now, Trillion meets and addresses 9 of the United Nations Sustainable Development Goals. Out of the 17, we are addressing 9 of them. So, next slide, please. Yeah, very much. So here is by the WIFE combustion model. Here we're going to show you how the hydrodiesel performs on a combustion basis. Next slide, please. So diesel, biodiesel blends, and hydrodiesel combustion modeling heat release based on the WIFE model. So the WIFE model simulates combustion and soot formation in conventional diesel bio blends and can be used for hydrodiesel fuel modeling. Okay. So this is a really important, like people will say, okay, you're adding water or you're infusing water in the fuel, how can you have more heat release? So we're going to explain that here shortly. So in most applications proposed to date are based on law, normal distribution, and continuous random variables, the best known as the WIFE model, which we're going to be talking here shortly. Next slide, please. So here it gives you an example of how the formation of hydrodiesel is achieved. So here you're going to see on the left, You have your water inside infused, and then you have your brown ring, which is the chemical package that we refer as to HDAS, hydrodiesel additive solution. We have a patent in the US, we have international patent as well. And this is what helps with the formation of the emulsion in conjunction with our smart blending systems that is specific and very detailed blending methodologies that we develop. So here, the droplet size form is called the micelle. Okay, so your water infused in the oil will not touch your engine components or fuel lines or pump or tank. It will be infused. So as it goes into the combustion chamber, it is superheated, expands, and since the boiling point of water is lower than diesel fuel, for example, then you're going to have a micro explosion. So now you're going to have lots of tiny droplets of diesel fuel, which is going to be fully burnt. And that's one of the reasons we reduce soot up to 90%, which is all the unburned hydrocarbons. Now we're going to burn most of the hydrocarbons. Okay, and since we have the water in there, we're going to have a slight ignition delay, and that will also help to reduce the soot and increase efficiency overall. And with the water, superheated water vapor, now we have an extra compression, and then that's what gives us the extra torque, an extra boost there on the from top dead center down to the on the piston. So, next slide, please. So this is expect more with hydrodiesel. You will increase horsepower, you have better efficiency, more acceleration, it will run smoother, it will be less friction. The engine will last longer as well. You can prolong your maintenance intervals because now your engine oil will last longer, and you can prolong that. And then having a better lubricity on your engine oil, now your turbochargers, you're not going to have clogged up injectors due to carbon deposits or clogged up, or valves are not going to be, all carboned up. So hydrodiesel will basically decarbonize the engine and clean it. So here on the right is a picture. On the left, you see hydrodiesel regular, which is a 700 nanometer droplet size emulsion. Okay, and on the right is one called hydrodiesel plus, which is a 50 nanometer droplet size emulsion. So we are developing this. It should be out in the market here in the summertime, the hydrodiesel plus. And both of them work great. Both of them, are excellent in terms of reduction of emissions performance. The added value of hydrodiesel plus is the shelf life will be 2 years or so. So that's what we're going to be bringing out to the market here soon as well. And then when it comes to intermixing capabilities, it has no limits on intermixing 90-10, 80-20 with the base fuel, and reduce viscosity, reduce density. So this is superior than hydrodiesel, but both of them work really good. Next slide, please. So conventional hydrodiesel and biodiesel with hydrodiesel intermixing capabilities. Again, with the normal hydrodiesel fuel, we have a maximum of 50-50 intermixing, okay, capability. And then with the hydrodiesel plus, which is the nano-emulsion, we have no limits on that one. And hydrodiesel is a fill and go solution, can intermix with no adverse effects. Next slide, please. So how does a water and diesel fuel emulsion increase power in diesel engine? So that's a question everybody is like, okay, can you explain more? Well, the WIFE model explains that. So water and diesel fuel reduces soot formation, increases fuel burn efficiency. And soot and unburned fuel, is a sign of lower combustion efficiency. So water improves sustained initial fast heating rate by a factor of 1.5. And you can see here on the right graph how hydrodiesel will have a more heat release on the right. And then by a factor of 2 for turbocharged engines. Next slide, please. Hydrodiesel fuel increases efficiency. So we have less soot, We have more fuel is getting burnt. The micro-explosion phenomenon has a big effect on that. So now we're burning most of the fuel, clean and enhanced combustion, and we don't have that PM and soot polluting our environment. Okay, next slide, please. And then including the HYDRODIESEL enhanced fuel injection performance. So a lot of questions that we get is, okay, can you fuel work on high pressure common rail systems? And the answer is yes. So the higher the pressure, actually better for us, because now we are actually reducing the droplet size of the emulsion, which in turn will increase the performance in the combustion process. So yes, we can definitely use the high pressure common rail systems and different injector types, and HYDRODIESEL performs really well, as you can see here on this graph. Here you can see on the right, the droplet count is improved versus the regular fuel. Next slide, please. So power increase as well. Lab tests we done shows 2 to 17% increase. It's a better fuel, better heat release. You can see here on the right, we have done these tests, and you can see that HYDRODIESEL fuel has a better heat release, even though we're adding water in the fuel, and it has an ignition delay of 2 to 5 degrees, and with that is helping reduce the PM levels. Okay, next slide, please. Okay, we did some tests with a major cruise line ship. We're under an NDA, we cannot disclose the name, but the tests were completed early last year before the pandemic, and the results were really good. Next slide, please. So the test was conducted on a brand new 6-cylinder diesel engine. It was coupled to a generator, 80 kilowatt generator. Okay, it was broken in 50 hours, and the tests were completed. Well, it looks like there's an error there, but the fuel performed really well. We had ultra low sulfur diesel, and we have HYDRODIESEL as well. We reduced the fuel economy was improved by 15%, close to 15%. The NOx was reduced up to 40%. The PM levels were reduced in all loads greater than 50%. Okay, so it was really exciting about that. And one thing that we learned over the years is that when the engines are new, the reductions are a little less than what we claim. But as the engine ages, the reductions are using HYDRODIESEL fuel are greater. And one other test we conducted as well, this cruise line, is vibration tests. We did noise tests. So, I mean, you can hear it, HYDRODIESEL runs a lot smoother, and we put the test on the instruments, and it was really good results. Next slide, please. So another good attribute that the cruise line learned was that the engine oil was cleaner. They acknowledged that, yes, we used less engine oil and less downtime, and over time, in a year period, let's say, we will have to do less maintenance, less oil changes, less downtime, and less soot, meaning that now the scrubbers now don't have to be cleaned as often. Okay, you don't want the risk of them getting clogged up or catching on fire. Other yacht owners as well, they were there, captains, they mentioned about transom on yachts. They don't have to go and clean that every time they go to port. They also learned that HYDRODIESEL, with the amount of reduction in soot and PM, now when they go to port, they don't have, they're not contaminating the port environment, causing harm to the workers and staff breathing the contaminated air. Next slide, please. So specific fuel oil consumption, this is a graph I would like to share with you that we did on that test with the cruise line. So here you can see we did 6 different loads up to 80 kilowatts, yeah, 78.3. And at each load, we had a better fuel consumption based on the net calorific value from 4% to 15%. So hydrodiesel is a fuel that will be an immediate solution and can be implemented right away. It would cost the same price as you pay today on your base fuel. It will reduce emissions. It will improve performance. You know, it will reduce fuel. It will give you a better fuel economy, and you will reduce your maintenance up to 20%. So this is really exciting. They were really excited about these results. Next slide, please. So this is total PM, particulate matter, and Bosch number. So this is some real results as well. And you're going to see here in each of the 6 loads, we had less soot, less PM on all loads, over 50%. The very first one at 13.4 kilowatts, we had 45.5% reduction. And all we did was just switch fuels. We ran hot diesel fuel and then switch, and then the results were immediate. Next slide, please. NOx reduction here was up to 40%. So 6 to 40% in all 6 loads. You can see we reduced quite significantly. And again, this was a new engine. And what we're seeing is as the engine ages and is used, these reductions or increase quite significantly. So new, the engine would be running at its peak performance, and as it ages, it pollutes a little more and more and more as it's being used. Next slide, please. Hydrodiesel fuel and next generations. Next slide, please. So hydrodiesel is a fuel that everybody wins. So the consumer wins, lower costs, healthier air they're going to be breathing, increased power. They will have an extended life on their engine, their assets, give you better fuel economy, and they can save with hydrodiesel fuel. The environment will win as well. So we're reducing, significantly the greenhouse gases and PM, and so the environment wins as well. Industry will win. So again, going to these refineries that have to reduce sulfur and they have to invest hundreds of millions to comply with the industry, and now we have them finding new ways to reduce the sulfur. Well, with hydrodiesel fuel, all we have to do is just implement a smart blending station or a smart blending system using their existing infrastructure, and they can start reducing the sulfur content immediately. Within 4 months' time is our lead time to get a smart blending system set up. So industry will win as well, and government will win as well. So we have, for example, governments that import fuel 100%, and they're always trying to find ways to reduce their imports. Well, with hydrodiesel fuel now, we can have smart blending stations at that location or in that region or in that country, and now they can reduce imports up to 25% within 4 or 5 months, which is quite exciting. Our lead time is 4 months for the smart blending system, and then the infrastructure is already there that we can use that, or we can use new infrastructure. So for the government level, this will be really good. We learned, from some governments that we're speaking with at the moment, that they see solutions that they like, but these solutions will actually harm their economy because taking cash flow from one side to help the solution to come in. But with hydrodiesel fuel can have the economy booming and at the same time reduce imports and improve the air quality of their nation. So win-win for everybody. Next slide, please. So next generation hydrodiesel, you can see here on the top, we have MGO on the left. In the middle, we have MGO hydrodiesel, okay? And then we have on the right is MGO nano hydrodiesel, which is hydrodiesel plus. So you can see they look the same from the base MGO to the hydrodiesel plus. They're exactly the same. There's no difference. And that's because there are droplet sizes as 50 nanometers, and the wavelength of light can go through and it becomes transparent. And you can see here in the middle picture, that's actually low sulfur diesel. And we're going to be getting into, you know, jet fuels, hydrojet, and all these other fuels here coming soon. Next slide, please. And thank you very much for your time, MTCC. Thank you for having us. We're really excited. We're looking forward to networking and creating partnerships in the Caribbean. And I look forward to hearing your questions. And remember, with hydrodiesel, just fill and go. Thank you.
Thank you, Mr. Gomez. Thank you for always giving us such an interesting insight into what the work is being done by Trillion Energy. Numerous technological advancements going on, proven options that reducing emissions and still meeting 9 SDGs. I mean, that's really great work being done by a company. So now we would keep the momentum going. We also want to move along to our other key speaker. We have with us another fuel provider representative. He's Mr. Kevin Motilal. Mr. Motilal is currently employed at the Trinidad and Tobago's National Petroleum Marketing Company Limited, where he serves as the general manager of the core business support with oversight of LPG business, quality management, and operations in Tobago and Dominica. So I would like now to invite Mr. Motilal to present another fuel provider's perspective on the current and future plans for decarbonization.
All right, good morning, everyone. Good morning, everyone. So as soon as I share, right. Just making sure. Excellent. So, okay, so thank you for having us present. So I'll get right into it. So basically, it was most interesting when we were asked to do this. So, of course, the evolution of the marine market, it started with zero carbon emissions, was wind, and of course, well, muscle power. Then it moved to coal, where there was steam propulsion using coal initially, and then eventually using fuel oils to generate the steam, converted to the hydrocarbons in the 4-stroke initially, and then 2-stroke engines, and of course, where we are now is what's next. So National Petroleum is a wholly owned state company, and we are one of 4 companies that provide a bunkering service in Trinidad and Tobago. Our business currently is primarily on the hydrocarbon side. However, we did take a look, and so I'll go through the presentation and then I'll give my thoughts on it, on where we are planning to go afterwards. So as a supplier, we need to know where the bulk of the vessels are going, what type of fuel they'll be requiring. So with respect to the targets, so the International Maritime Organization, they have set the target of 50% reduction in greenhouse gases by 2050. Of course, now, and just as has been done in the automotive industry and some of the other industries, it is governed really by regulation. So once the governments set the regulation, or the regulations are set in law, then the industry has to conform and to change their designs, or maybe modify the designs, or maybe come up with new designs, of course, and to try to achieve the targets. Keep in mind that with respect to engines, so you could do it 2 ways. You could have improvement on the engine designs. So, well, the maritime industry, just like the aviation industry, is generally slow to change. The automotive industry is a little bit more advanced in it. So they would have considered initially, when the initial sets of targets were set, they were improving on fuel efficiency, more fuel efficient engines, So there was some change in the technology on that side of it. And on the, well, of course, a large part of emission depends on the fuel that's being burnt. So that's why you started to get reduced sulfur levels, right? Where you reduce aromatics and some of the other more complex chemicals that contribute towards the emissions. So they were, so the fuel is a large part of it. And of course, with respect to technology, so there's always incremental improvement, and then there's the total change out. So that's why you have the hybrid vehicles, you have the electric vehicles, fuel cells being considered. So that's really where the shipping industry is at this point in time from our perspective. As a supplier, we look at the different options. So you have the carbon fuels. So as I say, we traditionally bunker the traditional fuels. We have been considering that the market is going towards, so the different options for fuels are like the low carbon ones, so like the liquefied natural gas, of course, liquefied petroleum gas, which is propane and butane, and the methanols and the ethanols. Then you have the carbon neutral fuels, or what are considered carbon neutral. So you have a mix of traditional fuels with the biofuels, the biomethanes, the synthetic methanes. And of course, you have those that are considered zero carbon emissions, so like the hydrogens and the ammonias. So just thought it interesting to include this slide. So it really gives the energy density of the various fuels used. So you have, of course, the top four are the traditional diesel vehicles, diesel fuels, hydrotreated vegetable oils, the theme, it is really the biodiesel. So they are basically similar with respect to energy content. Just below that, it's LPG, which is propane and butane. And that is just almost as good as those fuels. Of course, you have the ethanols, LNG, methanols, ammonia. Then you have hydrogen in its different forms. So you have liquefied hydrogen, which would be, well, I guess, and ammonia would be cryogenic. And of course, you can store hydrogen as a gas. And of course, lithium-ion battery. Now, based on the research, I think there's a ferry between Sweden and Denmark that is being outfitted to use the lithium-ion batteries. It's a 20-minute journey. It's a ferry, and it takes up a fair amount of space, battery space. So this is so that's why the energy content, well, the energy density is relatively low compared to the rest. So that might be lagging, and I really didn't address it in this instance, because even the trip between Trinidad to Tobago, it's at least 2 hours with the fast ferry. So that is still in development, and as I said, I didn't really address it in this presentation. So with respect to the liquefied natural gas, so looking at the specific options, of course, Trinidad and Tobago has a liquefaction plant. Natural gas, we realize a lot of the ships are going, this is the more popular alternative within the shipping industry at the moment. It produces almost no sulfur oxides and very little particulate emissions, has low nitrogen oxide emissions, and there's a significant reduction in the greenhouse gases. And of course, it reduces, when it's used in conjunction with the diesel and some other fuels, it significantly reduces the amount of carbon dioxide produced or released. There's a reduction cost due to the higher availability around the world. And of course, some of the challenges with it. So it's not zero carbon dioxide emissions because it is carbon based. It is a hydrocarbon. You have to consider methane slip. So with the some of the existing engines, if there's unburnt carbon or unburnt fuel, the methane goes off into the atmosphere. And of course, methane is harmful to the ozone. And of course, it's a relatively high capex for the LNG infrastructure to set up the bunkering system. So, however, you need to consider with the fall in natural gas or liquefied natural gas pricing and the increased amount of LNG bunkering, the infrastructure may start to make, it is starting to look feasible. And you have been seeing increases around the world with it. LPG and methanol. So we do have a producer, National Energy the presenter would have mentioned. We have Phoenix Park Gas Processors Limited in Trinidad, who is a producer of propane and butane. The method they use is they strip the natural gas of its propane and butane before it goes onto the Point Lisas industrial estate. So specific to LPG, it is a possible alternative to LNG. It is a lot easier to store and handle owing to its lower vapor pressure. So it's much easier to liquefy. And that's part of the reason it's popular as a cooking gas in some countries. It does not eliminate, again, it does not eliminate the carbon dioxide emissions. And while there are a lot of LPG terminals around the world, there is not sufficient bunkering infrastructure for it to be reliable for the suppliers. And I guess, like us, a lot of people probably waiting to see exactly where the industry is going, right, before they set up the bunkering infrastructure. So I was mentioning PPGPL is a producer. However, based on information that they would have provided, the gas has been coming drier. So the natural gas feeding the estate. So obviously, so their production has been reducing. So at the current moment, 98%, almost 100% of their production is for the export market. The positive side to it is that they do have large storage capabilities and they can import LPG into the country. So LPG, while we may not be producing it to use as a bunker fuel, we can import it and have it used. With respect to methanol and ethanol, of course, we are a producer of methanol, not ethanol, but not in such large quantities. So these two present alternatives to the natural gas or liquefied natural gas with a similar profile to LPG. They typically use as drop-in fuels. They are easy to handle when compared to natural gas, or easier to handle, and they benefit from a well-developed global terminal network. So because it's moved around the world, you have a lot of storage on ports. At the same time, bunkering facilities are limited, of course, just like the LPG. And of course, the ships need to be designed to operate with special care because the gases are toxic and they are flammable. And alcohols, methanol and ethanol, they burn with a colorless flame. So of course, these things would have to be regulated on board the vessel and even when it's on storage. To use them safely, additional capex is required for storage and handling, whether it's on the vessel or at the bunkering site. And while the capex, again, it's not a large capex, as large a capex as for the natural gas or liquefied natural gas, the fuel costs are less favorable when compared to liquefied natural gas and LPG, right? So the prices are a little bit high. With respect to biofuels, again, always a possibility, and there has been, the marine industry has been using some amount of biofuels and mixing it with the traditional fuels, again, to assist in reducing carbon dioxide emissions. The challenge with biofuels is its sustainability. And even in countries that, the countries that collect the most, so countries like Switzerland, Sweden, Norway, they collect just about 60 to 65%. So even they too are not so, again, it's, I guess maybe it's human nature and we need to get at it, but those are the better ones. And of course, you have a lot of countries who really don't collect as much. So sustainability of the biofuels is an issue. With respect to the synthetic methanes or substitute natural gas or biomethanes, again, is another attractive option. And they are compatible with the current liquefied natural gas propulsion technologies. They can be considered carbon neutral alternatives when used in tandem with the carbon capture and fuel cell technology and the existing LNG fuel infrastructure, and can be easily repurposed to source both or to supply both fuels. Of course, it depends on availability of the renewable energy, and the production remains costly, at least in the short term. With respect to hydrogen and ammonia, so they are basically considered carbon-free. Of course, you use carbon to produce the ammonia and hydrogen in some instances. But these fuels, the fuels itself produce 0 carbon dioxide emissions. They burn clean, almost no soot. And of course, well, it is noted that, again, the trouble with it, as you would have seen in the energy density, the challenge of having a very low energy density. So you need a lot of space to store it on board the vessel. So of course, they will need to be remodified within the ship design. And I think, if I'm not mistaken, I think somebody in the first day would have spoken about ship designs and how that affects emissions. So there will be some cost implications there. And of course, it depends on how many shipping lines or shipping owners decide to go with those designs. While hydrogen is favorable, it is about 3 times higher than that of fuel oil. Its energy density is 4 to 8 times lower, depending on the hydrogen state. And if you remember, they keep it as a liquid or at a pressurized gas. Ammonia, on the other hand, weighs twice as much as fuel oil and requires 3 times the amount of space to contain the same amount of energy, right? So there are space implications. Hydrogen, there is a challenge, and I guess you could consider as a practical example helium balloons. So hydrogen and helium are similar type gases. Helium is a little bit bigger. No matter how good the quality of the helium balloon, the helium always escapes by the next day or the third day, second or the third day, you find a lot of the helium would have gone off into the atmosphere. And it's a similar challenge to store it on board vessels because the molecules are so tiny. Right, so for ammonia, the process of storage and transport are well established because it is shipped around the world. It is produced up to about 190 million tons per year. Trinidad is a producer of ammonia. So it is widely available. Now the marine bunkering infrastructure would need to be developed. And of course, from a supplier's perspective, it depends on how many vessels would be calling at your ports for the ammonia. And of course, there are safety issues with respect to its toxicity and its caustic properties, right? So there are, and of course, these will have to be regulated when in use. So keeping all the different fuels in mind, Trinidad and Tobago is a producer of natural gas. We do have natural gas, LPG, methanol, and ammonia. Specific to LNG, we did have some initial conversations with NGC CNG. So we have a power generating plant. So we have the port of Port of Spain, which is situated in Port of Spain, the capital of the country. PowerGen, that is the power generating company. They shut down their power plant probably about 4 or 5 years ago. And so there's excess capacity on the natural gas because we do have a natural gas network. So it is piped throughout the country in gaseous form, of course. In talks with NGC CNG, we realized that it really is a challenge, or it would be a little bit more technical to transport, although we have a liquefaction plant in La Brea. It is kind of technical to transport the liquefied natural gas to the sites. The beauty of the entire thing is that at all basically what you'd consider the 4 ports, so we have 2 major ports and we have 2 smaller ports. The port of Port of Spain and the port of Point Lisas. You have the pipelines, natural gas pipelines running close by or within close proximity. You have natural gas at the port of La Brea, and you also have natural gas where it actually comes on land. Well, one of the areas where they come on land is in Galeota, and we have the port of Galeota. So the thinking was really, as there's a challenge with moving the cryogenic fluids, having a liquefaction plant or packaged liquefaction plant on site, and then of course setting up the facility. And of course, another option is using bunker and barge. So the idea for the bunker and barge is that in the Gulf of Paria, so probably more than 20, 30 years ago, it was an ideal spot for bunkering fuels. In fact, it still is a good spot for bunkering in the Gulf of Paria because it's always calm. So it's easy for ship-to-ship transfer. Of course, we do produce methanol, ammonia, and LPG. And of course, even if we don't have sufficient LPG, it can be imported. We do have the infrastructure for it. And of course, the bunkering infrastructure would need to be installed. So from NP's perspective, and really in consideration of the regulations that the shipping industry has to conform to, really and truly, where we are situated as well, which is just outside the Panama Canal, we can market ourselves as a multi-product bunkering hub for the various fuels, for the various vessels. So that's really where our thinking is. So thank you very much for your attention.
Thank you very much, Mr. Motilal. You shared with us the work being done and the work being considered by NP. Thank you very much. It's always useful to know what is being done, the options available, both locally, regionally as well. Thank you. So moving along with our session, we have a slight change in plans. I would like to introduce our next speaker, Ms. Keisha Barcelos. Ms. Barcelos is the Senior Health, Safety and Environment Officer for the Port and Estate Operations at PLIBDECO. She's passionately driving the reduction of significant safety and environmental incidents in maritime operations. So now I invite Ms. Barcelos to present on the port's perspective for the current and future plans for decarbonization.
So good morning, everyone. First off, let me just start by extending apologies on behalf of Mr. Ashley Taylor, who could not be here today to present and participate in this sharing today. Right. Right, so first off, Tobago takes the perspective of the decarbonization as the new normal in maritime, in global, and in global affairs as well too. So for us to see this as the new normal, we still have to recognize that the maritime and shipping industry is vital to the global economy, right? The shipping sector is vital and has never more so been than in the recent months when it kept the supply of essential goods circulating across the world. With this, the IMO has set an ambitious goal of reducing shipping industry's greenhouse gases as well as its carbon intensity. For the scale of the challenge, to meet the scale of the challenge means that any solution needs to be comprehensive and involve every aspect of shipping. We have to recognize that the challenge is too large for any one organization alone, so that it calls for an ecosystem perspective that we all have to share, we all have to work together to achieve this ambitious goal. With that, we also have to recognize that for economic feasibility of decarbonization to continue, for the continuation of port operations and the sustainability and reliability, as well as the replicability of the technologies that we look to adopt, right? We have to ensure that whatever we adopt is also cost effective and it's reliable for us as well to sustain the industry. Right, so just a little overview of Port of Point Lisas. So the Port of Point Lisas is part of a larger industrial cluster of the Point Lisas Industrial Estate, which comprises of approximately 103 tenants and is dominated by large and medium-sized petrochemical companies, including methanol, ammonia, as well as natural gas processing plants. We have 6 berths. We handle containerized cargo, break bulk cargo, as well as general cargo. Based on port statistics for the year, I think it was 2019, the port on average has about 13 to 20 vessels called per week, and we handle approximately 14,000 containers per month. To achieve that, the port utilizes a fleet of primarily diesel-operated cargo handling equipment, including our mobile harbor cranes, the rubber tire gantry cranes, and other heavy-duty forklifts and stackers. In 2019, we would have gone through our process of air emitter certification. So we would have gone through some inventorying of the emissions that we have from our equipment. So that in 2019, we would have consumed more than 200,000 gallons of diesel to fuel the equipment, including our fleet of trucks. Based on 2019 estimate, the calculations, the port's cargo handling equipment generated approximately 22,000 metric tons of air emission, carbon dioxide being the highest. Particulate matter, oxides of sulfur, volatile organic compounds were of significantly lesser amounts. Additionally, we would have done an approximate estimation of what our hauler trucks would have produced. So that the estimate is based on about 300 trucks per day staying on port for a maximum of 2 hours. And that would have given us approximately 109 metric tons of CO2 produced per day. Right, so with that, we now focus and we look at where our emissions are. So the port-related sources would be things that are port direct, which would include our port-owned equipment and generators. It will be port indirect, which will include our port user trucks and the seagoing vessels. And then other indirect will be the purchased electricity that we utilize. So this is just a snapshot of 5 of our main pieces of equipment and some of the quantities of air emissions that is produced for a year, right? So you see that our RTGs produce our generators actually produce the highest, and then we have our RTGs and mobile harbor cranes. So what are we doing now? The digital information flows are driving the automation of processes and functions that can have a positive impact on safety, commercial, and environmental performance. Digitalization is important to greenhouse gas emission reduction as it is recognized as a tool for efficient information gathering and exchange and analysis. So with that, we would function on our port call optimization, which is like the Navis and the TT-Biz link, which provides us with a platform to inform and optimize operations and move cargo efficiently. Our next approach would be under electrification. So we view it that to begin mitigating the emission problem from cargo handling segment, because that's what we could control, our equipment, our operations. The seaport cargo handling equipment and such as forklifts are being included in the decarbonization and sustainability plans. So the port has started doing this through the electrification and use of alternative fuels, thus to a lesser extent, right? So the electrification refers to the process of replacing technologies that use fossil fuels such as coal or natural gas with technologies that use electricity. So the port currently operates our premier berth, our berth 5, where we handle most of our containers, with 2 electric powered gantry cranes, and as well as we provide the facility, which we call our reefer yard, for the storage, which facilitates the non-fossil fuel generated power for the storage of refrigerated containers. So we have the facility where vessels won't have to keep running the vessel to just power the reefer containers. They could take it off and we have the electrical power to have it stored here for them. Right, so as I said, to a lesser extent, but we have started the transition of some of our forklifts, specifically for warehouse and in the hatch operations, because of the lower fumes that these type of forklifts would produce. So we now have 4 LPG powered forklifts, and we're hoping to increase this as well as maybe other equipment that will produce lower emissions. So what are we doing next? So it is our hope that by 2020, we can aim to make a 40% reduction in our carbon dioxide and sulfur dioxide emissions. So to achieve this, we will propose to look at specifically the port direct, so sources directly on the control of the port, such as the cargo handling equipment, and 2, the port indirect sources, which will be associated to the ships, trucks, and external trucks, that is, right? By implementing the following solutions, we look to achieve this through the following solutions, right? So firstly, we look at exhaust efficiency. We look at the port call optimization, introduction of green slots, carbon offsetting, and finally collaborations with other entities. So I'll get into each one of these now. Right, so with the exhaust efficiency, we would look to do the upgrades of our engines to the Tier 4 engines. We will look to do diesel engine retrofitting. We have to remember that these pieces of equipment, they were supposed to be lifelong assets. So to make a change to a completely new piece of equipment, it's a big capital expenditure that we will have to put out. So we could look at the retrofitting of the existing diesel engines, team with our OEM providers, such as LIBOR, to upgrade our engines from our Tier 3s to the Tier 4 engines. We will now look at the alternative fuels, as well as to increase the electrification of our process. There are currently plans in place to develop, in the development stage, to upgrade our new RTG area with more electrical panels, so that we can now further facilitate additional reefer storage and then reduce the need for our diesel-powered generators. Right. So now we'll go further into more of the port call optimization. So the aim here is the aim of the measure is to reduce the time spent waiting at the port, right? So plans will include gate automation, which will reduce and eventually eliminate the waiting of trucks then to the port. To increase the direct delivery. So we currently do direct delivery for a lot of our dangerous cargoes, such as the fireworks, ammunitions, those highly flammable ones that we don't want to really store at port. We kind of do those direct delivery. So the aim is to now increase what we do with direct delivery, and that will reduce the amount of equipment that we use to move the cargo from off the vessel to the truck or to additional storage. Then we will also look into research into the vessel call software. Pronto is a good example that will allow the ships to optimize voyage speeds, which in turn will avoid the excessive use of the fuel and thereby reduce greenhouse gases, right? It will also assist with the just-in-time arrivals and the slowing of the vessel speeds to reach its destination. Right, so what we can also look at as well to assist in the global maritime for vessels coming to us outside of just what we could do within our operations would be to provide what we want to call green slots, to provide incentive to the fuel for vessels that come in with fuel efficient or lower carbon vessels. We could provide them with an incentive for coming in with those types of fuels, or those who have upgraded or retrofitted their engines, right? We could also look at the collaboration with other fuel providers to set up infrastructure right here on the port, because we have Ventrin, who's already located on the port. We also facilitate the bunkering. So if we can now maybe upgrade our berths with these cleaner fuel infrastructure for bunkering, that would be also a way that we could promote meeting the goals. Right. So then we will look at the carbon offsetting, which is the activity that compensates for the emission of CO2 or other greenhouse gases by providing an emission reduction elsewhere. So as the landlord of the industrial estate, we're kind of in a good position, because I mean, we have land at our disposal that we could do ventures or initiatives such as the allocation of a land space for the planting of carbon sequestering trees. And now we can team with other persons on the other companies on the estate, right? So we have 103 tenants on the estate. We can now team with them where they can adopt trees, and we can have green spaces on the estate itself. If not on the estate, we can now promote it within the companies themselves. They can have green spaces on their plants as well, because they have lots of hectares of land, right? And we can use these things for green spaces. With that, we could also continue our mangrove reforestation projects. So we know that PLNL right now, they are doing a project for the reforestation of mangrove just north of the Couva River. So they're working with us where they're going to set up like tidal gauges because they need to do some tidal studies just to see, they're seeing some dieback in the mangrove. So they're just going to do some further studies, and then that's just something else we could team with to continue that process. Right, so we have also started and embarked on a project where we would have assessed our lighting on port, our high mast lighting on port, to see the feasibility of using solar panels to power that lighting. So that's just another project we have on the carbon offsetting side of things. Right. So finally, so we are seeing a new paradigm evolving and the opportunity to fast track change through practical and viable solutions will have to have this movement. How to make this happen? Collaborations within the shipping industry, governments, and across the borders of shipping ecosystem is critical, right? So what we're seeing is that the existing coalitions are starting place, and it is critical to build on the momentum and work together to drive the real and practical change for the future, right? So what we're saying is that we want to maintain these collaborations with the MTCC. We've seen that, for example, Lloyd's Register has launched a dedicated center for excellence to accelerate the safe and sustainable and cost-effective decarbonization of the world shipping in support of delivering the greenhouse gas reduction. A lot of us are ISO certified under Lloyd's Register, so this is a good opportunity for us, especially as a port, to get on board with this, right? We also see that Maersk is doing things with the biofuel. So Maersk is one of the shipping lines that comes to our port as well. So now we could do further teaming with these organizations to achieve what we need to achieve. Right, that's it for me. So thank you again, everyone, and we await any questions that you may have at the end of the session.
Thank you, Ms. Basalos, for stepping in and giving us some insights into the works being done at PubDeco, for sharing the emission calculations done within the port and the plans to reduce such emissions, and also for your interest in collaboration. We look forward to this. Thank you very much. And moving on to our last speaker for the session, Mr. Raval Ramstrup. Mr. Raval is currently employed as the HSC manager at Delta Logistics Limited. He specializes in maritime safety, security management systems, and marine assurance. He worked previously at Paria Fuel Trading Company Limited and the Petroleum Company of Trinidad and Tobago, has experience in port operations, quality management, engineering, and maintenance. So I now invite Mr. Raval to present on an operator's perspective for the current and future plans for decarbonization.
Great. Good day, all. Thanks for having me. We just try to pull up my presentation. Suzette, are you seeing my screen?
Yes, we're seeing your screen. Do you want to share it and present to view?
No, it's fine.
Okay, thank you.
Okay. All right, so my presentation is entitled, Delta Logistics Limited, our current and future plans for decarbonization. So just a quick overview of the company. We've been offshore marine service provider since 1982. We specialize in offshore supply vessels. In terms of our vision is to be a world-class marine service provider, and we intend to do this via three aspects, which is world-class vessels, world-class capabilities, and of course, competitive pricing. So that's a quick overview of what I'll be going through in my presentation. So I'll be giving you a quick overview of the industry, what a typical PSV operating profile looks like, the IMO's approach to emissions reduction and how that impacts us, and then our current decarbonization initiatives and future decarbonization initiatives. So that's a quick overview. So what do we do? Offshore supply vessels. The easiest way to summarize that is from beacon to beerite. What do I mean by that? We transport everything from shore to platform and back. That includes food supplies, that includes drilling supplies like drilling fluids, drilling pipe, we transfer fuel. Basically everything that you need to run an operation offshore, that's what all vessels transport. So we sometimes also do other functions such as safety standby as well as seismic support. And key thing to note about the industry is the dynamics are shifting more to the industry needing to be more efficient. Reason for this is, for one, charterers traditionally pay fuel costs. So it's in their interest to have the vessel run as efficiently as possible because they'll save as much money as possible. The other aspect is that now we have this shift towards reducing emissions from BP to Shell. All of the oil majors are putting a lot of focus on this. So they come to us operators to look at how we can improve efficiency. The other aspect is we are adapting, lessons learned from some of the more developed maritime segments, such as the larger vessel segments where they've more readily adopted different energy efficiency technologies. These are now trickling down to offshore supply vessels. So this is just a quick profile of what a typical large OSV will do over an entire year. So we broke down the operations into 6 different modes. So you have import, you have standing by, which would, in essence, you may be outside in the fields, basically waiting for operations to occur. You have DP, which is dynamic positioning operations, where the vessel will be working on standing by on a particular position to operate by the platform. We also have economic sailing mode, normal sailing mode, and then maximum sailing mode. So in the case of this PSV that we use, eco sailing mode, this vessel is outfitted with 4 generators. It's a diesel electric vessel. So eco sailing mode, you will actually run 2 of the 4 generators. Compared to normal sailing mode, you may run 3 or 4. And then maximum sailing mode is running all 4 generators at the highest RPMs. So the thing that really stood out is you can see how the percentage of time spent in each of these different modes, and I'll kind of get more into how we could become more energy efficient by focusing on reducing activities in particular modes. And the other thing that stands out is, in terms of fuel consumed per year, this vessel consumes about 780,000 US gallons of diesel. That translates to about over 8,000 metric tons of CO2 emitted when you actually do the calculations. So in terms of the IMO's approach to emissions reductions, MARPOL Annex 6 is probably the governing framework for this, and it impacts us directly as an operator. We kind of looked at it from 2 perspectives. So you have the design and the technical perspective, and then you have the operational perspective. I won't get too much into these, but in essence, you have Energy Efficiency Design Index, which focuses on new build ships and so around the design of the ship and making the design as energy efficient as possible. You have EEXI, which has been newly introduced, so it's about to be introduced, which is focusing on making existing ships more energy efficient by design. And then on the operational side, you have the Ship Energy Efficiency Management Plan, which is in essence a document that kind of lays out your energy efficiency methodologies and how you're going to become more energy efficient by making decisions on board. And then finally, there's also a new measure called the Carbon Intensity Indicator, which hasn't been introduced as yet, but it's the key aspect is the Ship Energy Efficiency Management Plan is not auditable. So when the flag state comes on board to inspect your vessel, all they check is to see that you actually have a Ship Energy Efficiency Management Plan on board, but they're not actually checking to see if the measures are properly implemented. The Carbon Intensity Indicator is intended to change that, where you make these operational energy efficiency measures auditable by the flag state. So, for example, if you go for 3 years and you've not improved your energy efficiency, you will likely have to submit a corrective action plan to the flag indicating how are you going to make your operations more energy efficient. So in terms of what are we doing to decarbonize, so on the design front, our approach is, look, we continue to invest in fuel efficient designs, optimized for regional weather conditions. And how do we do that? So the first thing is we've invested in diesel electric propulsion. So our last 4 vessels that we've added to our fleet have all been diesel electric vessels. This differs from a traditional prop and shaft arrangement, where you have a shaft running from the main engine all the way down to the propeller. Instead, you have generators on board that feed an electric motor. In essence, it's supposed to be more efficient, and in some instances, you can save as much as 15% compared to regular conventional propulsion systems. The other aspect is around design choices. So the vessel designs that we've picked, we've consciously made design choices to be geared towards energy efficient design, such as like the bulbous bow. So out here, the Delta Admiral, we chose to design out a bulbous bow to reduce drag and therefore improve energy efficiency. The other aspect is the drive types used. So we've picked azimuth drives as well too for our last 4 vessels. What that allows more, what an azimuth drive is, for those who are not aware, it's a drive that can rotate 360 degrees. So you can direct your thrust more efficient. That also helps you to reduce fuel consumption, especially when you are doing dynamic positioning operations. The other aspect is draft optimization. So if you can design a vessel with a shallower draft than conventional, that is conventionally used, that reduces the vessel's the amount of drag that can occur while operating, and will reduce fuel consumption. And then finally, optimizing deadweight to size. So what does that mean? So you want to, in essence, pack the vessel with as much cargo carrying capacity as possible. So you minimize unused space on board, so you can deliver as much cargo as possible. So you're benefiting from economies of scale in a sense. So just an overview. So this is the Delta Admiral, which I would have been highlighting. So in essence, you can see some of the design choices here. So the vessel is outfitted with azimuth drives in the aft. It's outfitted with a bulbous bow. It's a diesel electric, so it has 4 generators, and it doesn't have a traditional shaft running all the way from the forward of the vessel to the aft. So on the operational side, what are we doing? So the main thing that we use to reduce to improve our energy efficiency is the Ship Energy Efficiency Management Plan. Some of our current initiatives coming out of that is so the first thing is we actually actively measuring fuel consumption, setting targets. So the only way you could improve is by measuring and then setting targets for improvement. Other things that are contained in our Ship Energy Efficiency Management Plan are preventative maintenance measures such as hull cleaning. Hard fouling, such as barnacles, can improve fuel consumption by as much as 30 to 40%. We've actually seen this in times when we've kind of not completed hull maintenance as frequently as we should have, and we've seen our fuel consumption go up significantly. Main engine / generator maintenance as well too, ensuring that you do those on time is one of the best ways to ensure that you improve your fuel efficiency. And then the other aspect is by crewing awareness and training, so promoting energy efficient behaviors on board with the crew. So running weather patterns. So while you're out in the field, don't run on all 4 generators, Go down to 1 generator, follow the natural weather patterns while remaining within, acceptable distance of the installation. Optimizing generator use. So you don't need to run on all 4 generators if you don't have to, right? Go down to 1 or 2. And even something like HVAC utilization. In the tropics, you don't necessarily need to run the ship's AC system at 16 degrees Celsius, having it icy cool, you can run it at 23. And you'll be surprised how much fuel you save with these measures. But you won't actually know until you actually start measuring. The other aspects that we've been working on around this is we need to collaborate with the charterers, because they ultimately have control over the vessel from a commercial perspective. So they tell us where to go, what to do, how long to be there. So by optimizing, so we've actively worked with them with these type of initiatives. So optimizing transit speed, so just-in-time sealing. What does that mean? So if the vessel doesn't need to be in the fields for 10 hours or 15 hours, you don't need to go 100% on the engines. You can run on 2 engines, sail at a slower speed, and get there when you need to be there. Minimizing standby time / idle time while on DP. Sometimes they go to the platform, they don't need you at the moment. They might need you in a couple of hours to take a lift off the vessel. Okay, if that's the case, then don't stand by on DP. Exit the 500-meter zone and go down to 1 engine while you wait until they're actually ready for you. Efficient cargo route planning. So in essence, plan the routes of the vessel to be more effective. So instead of having the vessel going back and forth between 2 installations to move 1 lift, you try to plan better. right-sizing vessel capacity. So what does that mean? In essence, we would look at, if you don't need a 5,000 deadweight vessel to deliver cargo, then let's look at using a smaller vessel, because the client may only need about 2,000 deadweight tons of capacity. So if you supply a vessel as optimized, you reduce fuel consumption by that very option. In-field mooring is another one. So when the clients actually put moorings out there, so you can tie off in the field without having to run on your generators to standby. The other aspect is reducing transit time. So if the majority of your installations on the east coast of Trinidad operating from Port Galeota will reduce transit time. For example, going on to the east coast, all of the BP's installations from Chaguaramas takes about 12 hours. But if you operate out of Galeota, which is on the southeastern coast, it takes you 3 hours. So that in itself, that's 9 hours of transit time that you can save significant fuel. And then the last one would be DP ASOG optimization, which is where you set up your vessel during DP operations, and I'll get into that a little more. So just a quick overview of what actually the inside of a CM looks like. So, you know, it breaks down the different types of fuel saving measures that the company would like to do, and then it gives instructions to vessel crew in terms of what you need to do to ensure that these energy efficiency measures are actually being implemented on board. So that's a quick overview. And coming back to what I was speaking about, ASOG optimization. So in essence, when you're doing DP operations at an installation, the vessel needs to be set up with maximum redundancy, meaning that you need to set the vessel up with enough propulsion and power generation systems that if there's a failure, the vessel will not lose power and make contact with the client's installation. So in the case of this vessel, this is what it says. It says you need to set up all 4 generators while you're operating on the installation. But working with the client and installing certain systems on board, you can actually set up on 2 generators instead and still meet the redundancy requirements. Thus, you're going to be saving fuel in that way. So these are things you can do with the clients and charterers to reduce fuel consumption and improve our energy efficiency. Just coming back again to operating from Galeota, so this got a little overview of Trinidad. So this little dot here is the blue dot is Chaguaramas, and the yellow little triangle is Galeota. So what this would do, if you shift from operating to Chaguaramas to Galeota, you would save on these mode 4, mode 5, and mode 6, where you're actually burning your most fuel. You would save significant fuel by a simple choice of operating from a closer location, a closer port. Now it's a little bit more complicated because Galeota is tide restricted, so you have to do sailing with the tide, etc., etc. But you know, these simple inconveniences could still result in significant fuel savings, and it's worth it. So in terms of research projects that we have in progress, so we're also looking at a project where the IMO recommends the use of energy efficiency operator indicators to measure your energy efficiency. However, that KPI has not been optimized for offshore supply vessel operations. When you look at the formula actually looks at how much cargo you're transporting, as well as the fuel consumed and the distance traveled. And in the case of our offshore supply vessel, because you stay on one location for very long periods of time to load cargo between an installation, it tends to skew this KPI. So what we're looking at right now is, okay, let's develop a KPI that is more effective for offshore supply vessel operations so we can truly understand how energy efficient we'll be. Another thing we've looked at, so this is getting to future decarbonization plans. So we already looked at, and going forward, we're going to be looking at more the feasibility of alternative fuels. So we've already looked at LNG as a marine fuel for OSPs on one of our vessels, the Delta Admiral. And from our research, we've concluded that, yes, you can achieve significant emissions reductions, but the business case simply wasn't there. Reason being is you have to give up significant cargo storage space to accommodate the LNG fuel infrastructure. And the other aspect is you have massive retrofit costs. It was somewhere in the region of 5 to 6 million euros. And in the current market conditions, it just does not support the business case. That being said, moving forward, we're looking at other alternative fuels such as hydrogen, methanol, etc. Offshore supply vessels already carry methanol in some instances. So we're going to be looking at those type of projects moving forward. Just an example of the type of emissions reductions that we saw: 30% CO2, 85% SOx, 70% NOx, and about 60% PMs. But this is how much space you would actually have to give up on board the vessel to accommodate an LNG tank. Now, it's a drawback because the reason being is if you reduce your cargo carrying capacity, then you may need to make more trips. So the fuel saved by using the fuel that you might save or the emissions you might save with LNG, you may have to make more trips. And then when you look at the actual business case, it may not be worth it. We've also looked at battery hybrid propulsion systems. This is another promising one for us as well too, where in essence you're dropping a containerized energy storage solution on board the vessel that has batteries in it, which can then feed power to the grid on board. You can accomplish fuel savings via less running engine hours, downsizing of the engines, elimination of engines entirely, or increasing utilization and rate of engines. And you can get as much as 20% fuel savings depending on the mode of operation. So Seth, how am I doing on time? Just sorry to cut across.
You're doing well on time, and we're actually really on time, so you can continue, Raval.
Great. All right, so yeah, so you can, the benefit about these systems is you can actually customize the type of operation you want. So you can set the system up where you can benefit from peak shaving, performance boosts, flexible engine utilization, as well as spinning reserve. So you can actually, in the case of spinning reserve, you can remove, let's say you have 4 generators, you can remove 1 generator entirely and count a battery, the battery power system, energy storage system, as an engine for your power consumption needs. So this is actually a great option. Now the thing about it is all about application. So it's only really beneficial in instances where the vessel, based on the duty cycle of the vessel. So if the vessel involves constant periods of high loads, where you have to run at high RPMs all the time, then it's not, the business case is not very effective. It's not very good. But if the vessel is doing a lot of standing by, they have long periods of low loads or transient periods that swing from very low loads to very high loads, it's very effective. The business case can be made. And then also energy storage solutions can be used to complement DP operations. As I mentioned before, you can eliminate an engine entirely and use battery power as your backup power in case you have an engine failure, etc. Now, there's a high capital cost. When we looked at it, we're looking at anywhere from $1 to $2 million US, depending on the configuration to actually do the retrofitting. And unfortunately, the current market conditions affect the business case for us as an operator. In terms of potential next projects, so we've been looking at, we intend to look at greater utilization of shore power connections. So the majority of our vessels are actually outfitted with them already. However, we intend to do more studies around, okay, well, are the connections sufficient to run? They can run the hotel loads of the vessels, so your lighting, your HVAC, etc., etc. But can they actually run, or are they sufficient to run your cargo management equipment and your ballast and bilge systems while in port? And we need to do further research around that. It is technically feasible, but we may need to do some modifications on board to facilitate that. The other challenge in Trinidad is infrastructure. There's not a lot of, as far as I'm aware, the ports we operate out of, we don't have shore power infrastructure readily available. And that's more to do with the type of arrangements the port operators have. Most of our clients lease port space from a port owner, so they're not really keen to spend money on a shore power infrastructure system, seen as a leasing space, and then the very nature of the contract. They may invest money and then have to change ports that they're operating out of. So that's probably one of the biggest challenges with it. The other aspect we're looking at is external containerized generator sets. So these are just an extra generator you can drop on the vessel. And how you benefit from this is right sizing power generation. So in the case of a vessel like the Admiral, where you have 4 large generators on board, when you import, you might want to run on 1 generator. But let's say hotel loads are about 200 kilowatts. That generator might be capable of generating 500 kilowatts of power. So you may not be right sizing your power generation needs. So we can drop a containerized generator set on board that meets the hotel need and is very, it consumes fuel in a very efficient manner. So it is technically feasible. The classification societies already have a process in place for acceptance and approval of this. But further research is needed to see the business case can be made for it. And then coming on as well too, in terms of other aspects we're looking at. So you hear these terms all the time: IoT solutions, AI, big data. So how we intend to use this, or what we're looking at, is optimizing decision-making processes in the ship energy efficiency management plan with the use of big data and AI systems. So there are actually quite a few providers that sell solutions that can give you real-time information on how you can optimize energy savings. Kongsberg is a very big, they are big into this right now. They can tell you, okay, look, you're running on 4 generators, you can go down to 2, and you'll save X amount of fuel. And so these are the type of solutions that we're actively looking at. And then finally, the other aspect would be, formally incorporating the energy management process into our quality process, into Delta's quality process, which is looking at ISO 50001 certification, which is around energy management systems. And then finally, so what's the way forward for us to aid our decarbonization plan? So as a company, we don't think a carbon tax is the most effective way to do that for us as a local operator. We think the better approach would be is via incentives. So the biggest challenge for us as an operator in these current market conditions is charters are very short at the moment. There's a lot of uncertainty in the market. So, I mean, you can invest $2 million in an energy storage solution, but then you might lose your contract in 3 months' time. And then, it may be difficult to find work, and you have to pay back on these investments, etc. The other aspect is, okay, well, what about energy efficiency tax incentives? So maybe the government could look at incentivizing us as an operator to invest in these type of technologies via tax incentives, and that would definitely encourage us to take on these further investments. And then the other aspect too is, look, investment in infrastructure. So we can invest in an LNG fuel system, but then if there's no local infrastructure to actually give us LNG fuel, that's $5 or $6 million invested that we're not going to actually see returns on. So, we need to see that, and I'm glad to see a lot of the presenters today were, talking about today, actively looking at this. So it's a bit of a chicken or the egg situation, like, do we as the operator invest in infrastructure on board our vessel first, and then wait for the infrastructure investment to come afterwards? Or do we wait on them to invest in infrastructure and then follow afterwards? Unfortunately, in the market conditions, we have to be very, intelligent with our investment decisions, because we don't have the type of bankruptcy protections and financing options that the multinationals that we are competing against have access to. So we need to invest smartly, and the incentives are needed to encourage that, to help us as an operator to compete. And that's it for me. Any questions?
Okay, thank you, Raval. Thank you for telling us what's going on with Delta Logistics, what you guys are doing to reduce the emissions within the operations, especially as a local operator. It was really interesting and useful to see what projects are being considered, both the pros and the cons for it as well. At this moment, though, we would like if all our participants could put on their cameras to take our group photo. I would wait for Michael or Tevin to tell us when we should say cheese.
Tevin.
You can start all now.
Say cheese from all now. Okay. You let us know when it's completed.
Just waiting for a few more. Okay, we have plenty today. I'm going to take the first one. The second. Thank you, people.
Okay, thank you, everyone. So now, and being really good on time, I would like to hand over to Ms. Sarita to start off with our panel discussion session.
Thanks, Suzette. So that was, I think, a really successful, wonderful, and insightful morning session. And, it was really great that we had the different perspectives from shipping. So Raval, thank you for that. From fuel providers, from port as well. It really gave a comprehensive overview of what we're trying to achieve with today's session of decarbonization in the sector, not just from one point of view, but from multiple. So what I'd like to do is at this point invite the speakers from this morning, and we could go in order of how you presented this morning, to just give us your final views or maybe a key point from your presentation that you want the participants to take away with them from today. So Marcia, we can start with you.
Okay, sure. For me, I think in terms of one of the key takeaways from the national energy perspective is just certainly in terms of we would have done the groundwork in terms of looking at the market and assessing the market in the early part of 2020, and in terms of the work that is currently abreast in terms of seeking to implement some of those recommendations coming out of that report. The NGC, and in fact, it isn't across the entire group in terms of setting cross-functional teams to actually look at some of those opportunities. As I had indicated in the presentation, we have, in fact, would be looking very specifically at the LNG opportunity, and more so the micro LNG, I should say. Right, and I know that in terms of even the last speaker from Delta talking about in terms of the infrastructure and so on. I mean, those are things, of course, in terms as well, in, with National Energy having its own marine assets from the different ports and Point Lisas at Galeota. There are opportunities here for us to really revisit and assess our infrastructure and then determine the degree of readiness in terms of being able to really make this, make this a reality in terms of the provision of some of these alternate fuels. It's important to know that in terms of the facilities and the production for the facilities at Point Lisas and so on, they are typically not set up for small scale, just like we'd have the situation, of course, with Atlantic, where you have LNG and so on. They're not set up for small scale type operations. They're really set up for off-takers being from methanol tankers and so on. So you really have to revisit in terms of looking at assessing the infrastructure to facilitate this kind of operation. But certainly in terms of understanding that as a group and looking at the opportunities within the space, that we are in fact actively pursuing those opportunities. That's it for me, Sarita.
All right, thanks, Marcia. I want to also ask Mr. Ramesh Harilal, who's the Vice President of Operations at the National Gas Company of Trinidad and Tobago, to have some input here as we go into this panel discussion. Mr. Harilal has more than 28 years experience in the oil and gas sector, and he has worked at several gas processing automation projects in West Texas. We are very happy to have him here with us and to lend his expertise. He has also fulfilled various positions at Phoenix Park Gas Processors Limited since 1991, and he's currently the VP of Operations at NGC. So, Mr. Harilal.
Yeah, good. So good morning, everyone, and thanks for having me on the panel. So, certainly good presentations, and good to see, each of these presentations, certainly looking at, different aspects of sustainability, which includes, looking at different fuel options, battery storage options, and so on, to really help with the whole sustainability and green agenda. As Marcia would have pointed out, we do have as well, really looking at solutions to also link with, sustainability goals. So, just to add to that, NGC is also focused on reducing methane emissions, through systematic steps that includes, expert collaboration and compliance with emerging standards on methane reduction techniques and the use of data and technology. And while there are several emerging technologies and approaches to measure methane, that appear promising, NGC actually has started, implementing technologies to actually monitor and identify leaks as well, methane leaks along our network. And also we just recently signed an MOU with with a satellite provider to, develop algorithms to see how we can actually detect and measure methane, alongside our infrastructure. We are utilizing satellite technology to monitor our piping infrastructure across the island as well. And to be able to also sort of expand this across, all the energy industries in Trinidad and Tobago, as well as, see if we could actually utilize this technology even regionally as well in the Caribbean. But I'm available for, I guess, questions and to support Marcia here as well. So thank you.
Okay, great. Thank you so much. So I'd like to move on to our next speaker, Alex. You're still on mute, Alex.
Yes, Alex Gomez here. Yes, we have a big problem that we need a solution, an immediate solution, something that we can implement on existing infrastructure to start reducing emissions on a global basis. So yes, we have ambitions, we have plans for the next 20, 30, 40 years, and it's going to be a transition to get to that point. So from today to 2050 to 2060, there's going to be significant amount of pollution happening, and the reductions will be, gradually decreasing through time. But as an immediate solution that we can implement today in existing infrastructure, we strongly believe a solution like hydrodiesel fuel is a great option. These other fuels that are coming into the market, alternative fuels, methanol is a great option. It's clean. It has a very low flash point, makes it risky for storage and handling, has a low density, energy density of 22 kilograms per megajoules, or 22 megajoules per kilogram. And ammonia as well has about the same energy density of 22 megajoules per kilogram, but it's also very, very toxic. So those are great options to help fight climate change and pollution. Hydrogen, great fuel, high energy density, I believe it's 142 megajoules per kilogram. It has a little, disadvantages in terms of handling and explosive and those type of things. And I'm sure it's gonna be safe for us as we work on new ways to create hydrogen and store it and handling. And that's gonna take time. And then these electrofuels that's converting CO2 into fuels, that's also a great option. There got some companies that are implementing that. It requires huge infrastructure and this is the matter of time. So we're going to be seeing that in the next, decade or two, some more of that. Now the challenge is the infrastructure, the time to implement these alternative technologies. That's where the challenge comes in. So it requires huge amounts of funding, infrastructure, and is very limited production. So you build a plant and you have X amount of capacity, and then to increase capacity, it takes more time, more money, more infrastructure. So what we are proposing here with hydrodiesel fuel and hydrobunker fuel is, how about if we use the existing infrastructure that is globally running today, diesel fuel, tanks, piping, refineries, we use existing infrastructure. And all we're doing here, what Trillium is providing is a smart blending system, the know-how, we implement, and the results would be immediate. And we can reduce PM, NOx, CO2 on an immediate way. So that's what we proposing, and we're looking forward to being able to collaborate with parties in the Caribbean and help decarbonize the region. Thank you.
Thanks, Alex. Kevin?
Right. I think basically it's been reflected by all the speakers. Obviously, and I basically added in my presentation as well, there are many options. And of course, there is a cost to the infrastructure, or having the infrastructure in place. And of course, we have to consider the payback as a provider. And this is from a fuel provider's perspective. And I like the point Rival actually made with respect to having, concessions from the government, or whether it's tax breaks or concessions. And I was thinking, granted, this is a global issue, but as I said, we could, and Trinidad is in a decent enough position to market ourselves as a one-stop shop for bunkering the various forms of fuel, or the various types of fuel. So I think something like this, because when you hear everybody when I've heard from everyone, basically we seem to be looking in a similar direction, and so maybe we need something or someone to kind of pull us together, to pull the different entities together. I'm sure, and this is just us speaking, I'm sure the other companies are also looking in a similar direction. So.
Right, thanks Kevin. And I see Keisha was nodding along with you there, and agreeing with some of the points that you've made. So Keisha, your comments?
Yeah, so I echo the sentiments that the other speakers would have stated. But just one takeaway, I think that for us to really achieve this daunting task, we have everybody is now starting to buy in. What we have to do is continue with the collaborations and coalitions with groups such as the MTCC, continue with IMO to achieve this agenda, that the collaborations and sharing of information and working as one unit to achieve the goal is how we're gonna get it through.
Agreed. Raval? Raval, can you hear us? It seems as though Raval is having some connectivity issues. So I guess we can go straight into the questions aspect. And you all have been really active on the chat, which is great to see, because it means that you've been soaking up all that information and sort of, applying your own concerns and thoughts there. So what I'd like to do is to start kicking off with some of the questions that have been asked on the chat. So the panel can start to respond, and then you can raise your hands in the meantime, and we'll take those questions one by one, right? So just raise your hand and leave it up if you have a question that you'd like to ask out loud, and I will call on you when it's your time to ask. So we had a couple questions coming through for NEC, Trillion, and Tobago. So one of the questions for NEC was, what is Trinidad and Tobago's current methanol and ammonia output? Not the capacity, but the current output. So I'm not sure if you all have those statistics.
Okay, so thanks, Rita. And really to answer that question, the current production for the methanol and ammonia facilities, persons can in fact get those statistics actually out of the central bank. The central bank produces quarterly reports. There is in fact, the last report would have been January of 2021. And in it, you can find in terms of, they will give you, I think they go back, the last one, they were going back maybe 4 years. So last year, in terms of from the ammonia production for fertilizer, the exports would have been circa around 4.6 million tons per annum. And in terms of the methanol, it would have been, in terms of the exports, just about maybe about 4.3 million tons, sorry. Right, so that would have been, of course, understanding that over the last year or so, you would have had some of the facilities, of course, would have been mothballed and so on. So it would not have been in terms of what I would have presented, because I would have done it more on the capacity basis. But in terms of the actual production, those are have been the figures coming out of the central bank for last year. Right? But if persons want to see more additional information, I mean, the reports are public information available on the website.
Okay, great. Thanks, Marcia. And another one is, if all the plants return to full operation, can NGC supply their demand?
An interesting question. So let me see if Ram is still on. Ramesh is our
Yes.
Vice Operation. So I think this is a good one for you there, Ramesh.
Sure. I mean, of course, it depends on supply, right? And we all know that some plants have, have been mothballed for economic reasons as well as efficiency issues. So we do have, again, it's all dependent on supply. We do have some projected supply coming on board. You all would have seen publicly Touchstone onshore gas, and we're working closely with Touchstone to bring on those volumes targeted by the end of the year. Of course, we need to find a home for those volumes, and if plants remain down for economic challenges, then that is one of the issues. Yeah.
Okay, great. So thank you very much, Marcia, and Ramesh for answering those questions for us. I'm not seeing anything else at this point in terms of questions for NEC. So if any do come up, I will be sure to call on you all again. And I'm not seeing any reason. Yeah?
There's an earlier question about decarbonizing a fishing fleet. I think that might have been targeted to Marcia and Ramesh as well.
Okay. Yeah, so let me read that out. I saw Stefan had responded on the chat, so I didn't call it out yet, but yes, we had a question about small commercial fishing motors powered by methanol and access to buy methanol on the local market to modernize a local fishing fleet. So maybe on the topic of access to methanol on the local market.
Yes, so in terms of, as I was saying in the presentation and even some of the commentary afterwards, in terms of access to smaller and on the local market, there are in fact some local sales that the current producers do provide to local suppliers and so on. And that'll be for persons who have, whether not to be small processing or they utilize it in some form in their whatever production. But it doesn't go any smaller, unfortunately, any smaller than that. In addition to which, in terms of with regards to the methanol, there is still an applicability as it relates to the IGF and the ratification of it for it to be applicable to other types of vessels. So at present, a lot of the applications are, again, in terms of the tankers, you would find in terms of, because again, when you look at the use of methanol versus with regards to fuels as well, you have to also be mindful of the fact that you have to look at it in terms of its volatility and on the other aspects in terms of utilizing it. So the methanol though, I think once those requirements are in fact developed or approved or even ratified through the IGF, it could you probably will see some sort of catalyst for investment in either niche markets or in particular types of locations. But at this point in time, it still requires ratification for wider vessel uptake and for applicability. There's still a lot of work that is still going on as well, even through the Methanol Institute as well with regards to that.
Okay, great. Thanks, Marcia. So I see Raval has been able to rejoin us. Raval, would you just like to leave us with a wrap-up statement from you?
Sure. I guess I'll just, I really enjoyed the presentation that given this morning. From our perspective, even though I spoke a bit about the business case, not being able to be made for some of these technologies, the clear direction that we see the industry going now, our industry that is that energy efficiency is part of the way that you do business. Fuel savings is part of the way that you do business. So even though we may have some issues with the business case being made, it may reach a point where in order to be competitive, you will be forced to adopt these energy efficient technologies, especially in the supply boat sector, which is, I would say, overly saturated with vessels right now. What differentiates you from other operators at the moment is your ability to be energy efficient, is your ability for your fuel to run in a fuel efficient manner and consume as less fuel as possible, because at the end of the day, how it currently works is the charter in our industry usually pays for fuel. So forget just the need to save energy, to save emissions, etc. At the end of the day, for them, it comes down to dollars and cents. And I will hire your vessel if you can save me as much fuel as possible, because my operating costs reduce. There is a drive on there and as well to reduce emissions, but really that's one of probably the biggest driving factors, and it's leading all operators to have to adopt energy efficient technology, whether it's through some of the solutions I've listed, retrofitting your vessel, or capturing and utilizing big data type solutions to drive your decision making. I would say the other challenge we had when we were doing some of our research, especially around LNG, is there was a bit of uncertainty around what the actual price would be locally, because that information is not necessarily readily available. So we had to make some assumptions about what pricing would be. And I think that's one of the challenges that you have as an operator, is that, because this information is not necessarily readily available, that you have difficulties in generating your business case. The other thing I want to touch on is, even though our research indicated that LNG may not be the best solution for our vessel and maybe in our segment, there are other segments where it's been shown that it's actually very useful and can be applied, and there is a business case, such as ferries, such as tugs. So I didn't want to sing doom and gloom. It may not be applicable to our sector, may not be the best option for our sector. I think battery energy storage solutions are better, but it may be more effective in other sectors and for other vessel operators.
Great, thanks, Raval. And yes, I agree. It comes down to the cost, right? The dollars and cents, and what makes the operations more efficient in that regard. Okay, so I'd like to go into the questions for Trillian about the hydrodiesel. So Alex, you're on point. One of the questions was, what is the life cycle of hydrodiesel? And I think you did mention it at one point in your presentation, but if you could go a little bit more in detail as to what that life cycle is, maybe, and recap what you said.
Yes, absolutely. Great question. Yeah, so once we produce hydrodiesel fuel, our shelf life right now is 6 months time, okay, from production. And that is on a stationary basis. So if you have, for example, a tank and you fill it up, shelf life, we're saying six months time, water would not separate from our emulsion. So what we have is, you have a slight surfactant that falls off after 6 months time, but it still has calorific value and it will still burn. Okay, we are expanding our stability to 1 year, at least 1 year, with the hydrodiesel plus. Okay, so safer to put in your engine. Now, if the tank or the vessel has some slight agitation, and then it will be beyond 6 months time stability. This is the cycle of the fuel. And the hydrodiesel plus would be no limit, pretty much.
Okay, that kind of goes into the second question I'd asked about the stability of hydrodiesel as compared to the conventional marine fuels.
Yeah, so here, for example, the Gulf Coast, diesel fuel has a storage, the claimed storage life of 6 months time. So which is basically the same what we're offering. So we wanted to make it similar to what the market is, 6 months time. And that is basically on a quality standard basis. So the fuel, you can burn it after a year, you can still burn the fuel and it will burn. But if you take a sample and you want to bring it to the lab, if you want to analyze it to see if it meets the ASTM D975 standards, within 6 months time is where hydrodiesel will meet those standards. And then we'll slowly get out of those parameters as it ages a little more.
Okay, thank you.
You're welcome.
We have a couple questions for Deco now. So, Keisha, does Deco monitor the estate tenant emissions, and is the information available on the total estate footprint?
So yes, we do. We do monitoring of the tenants on the industrial estate via our quarterly monitoring. So just as they have requirements to report to the EMA, they have requirements to report to Tobago as well. So, and just to note that their requirement is based on lease agreements with Tobago, and our lease agreements are in alignment with World Bank guidelines. So it's a bit more stringent than some of the EMA requirements as well too. While we do have that information on record, we have not yet tabulated or collated it to determine what the actual footprint for the estate is. But as a project that we can look into and take on to have a better estimate of what the estate produces on a whole.
Okay, great. And I guess this is a two-part question, because right after that question was asked, another one was asked about does Tobago monitor and report ship emissions? Or will they monitor and report ship emissions in the future?
So currently we do not ask for or monitor the ship emissions, but that is something that we should and will look at in the future, because it would be easy for us to get that through a shipping notice through MSD to have them report on their ship emissions to us.
Okay, great. And last, for you as well, Keisha, it seems, any decarbonization initiatives undertaken at ports with respect to waste management that can be discussed?
So I saw that was from Ricardo, but just to answer his first part, yes, we did touch on the electrification. So we have a twofold type of electrification on port within our equipment, as well as electrical panels for the reefers, which I explained in my presentation. So that is a route that we are taking, the electrification of mainly equipment on the port. With respect to the waste management, not at this time. It's more of the indirect things, like maybe and the carbon offsetting type things, where we would recycle the dunnage or the pallets and those sort of things, but no major initiatives on the waste management for decarbonization as yet.
Okay, great. Thank you. So there was an interesting question that came up along the way about how does all of this affect insurance considerations? And I just want to put it to our panel today, if there have been any discussions with regard to that, or any anticipations with regards to how it may affect insurance issues for your operations. And that is with respect to the use of alternative fuel, the alternative fuels that we've been discussing, the storage of it, the impact of it, on your operations from the insurance side. I don't know if those were considerations made.
Excuse me, Sarita, is this question for me? I lost connection.
Anyone on our panel, so you can go ahead, Alex. Yeah.
Oh, okay. No, I didn't hear the question. I lost connection.
Okay. So there was an interesting point that came up about the impact of the use of these different types of fuels on operations and on the insurance side of it. So have insurance considerations been made when you look at the storage of it, the use of it? Has that come into play for any of our panelists today?
Yeah, so I can say a few words on this. So for an example, hydrodiesel fuel having a lower toxicity with a UN 3082 class 9, making it less harmful for the environment. It would be less harmful for the environment in the event of a spillage. So in our opinion, an insurance company will welcome our fuel quite well for having these attributes. Also, the flash point being higher than regular fuel as well at 61C now is safer for storage and handling. So that would also make a positive impact on the insurance company reviewing our product.
Okay, great. Any other panelists has made those kinds of considerations or looked into it?
If I may, Sarita.
Sure.
Yeah, okay. So thank you, Alex. I think that was very useful insight, because we are looking into technical options, and if I can reflect on some of the criteria when as an from operator's perspective, when we have these various options. First of all, I must thank you to all the presentations were very insightful, and looking at all of them, I feel like technical availability of infrastructure or reliable supply of fuel, the quality of fuel, the required quantity of fuel. These are some technical considerations from operators' perspective. We are all are aware of the environmental requirements, health impact, climate change, etc. Then obviously the social criteria of safety of the fuel, and most importantly, I would say the in view of upcoming legislation, how we see the journey towards 2030 or 2050 ambition from IMO's perspective. But the main, the fourth criteria, which I feel is very important and is being discussed, is economic, right? Investment cost for both infrastructure ashore and onboard vessel, including what would be the operational cost, OPEX, as we've been saying, and the fuel price, expected fuel price as we move forward, right? Because whether it is dependent on the oil and gas market, because if raw material is coming from there, or if it is dependent on any other sectors for the, what would be the fuel, alternative fuel price for the market. Now, given all that, my question is again to all the presenters here is the, the catch-22 situation which existed earlier, that okay, whether the market exists for this fuel or from operators, it was whether that fuel is available. Now I think that there is clarity coming, that the situation is clearing more and more. But how you think that, what is the biggest challenge in marketing these alternatives? For example, Alex, the hydrodiesel, what or from the NEC perspective or NEGC. So we are speaking about these alternatives which are available, and the data is speaking for it. But then what is the barrier in selling it to customers? I would like to hear if you can try to summarize and say, okay, this is the biggest challenge. For example, from Trillian's perspective, if I am the operator, I would say, okay, you're mixing fuel with water. It doesn't make me comfortable until you prove it to me, right? So things like that, what is the biggest challenge or barrier you see in marketing of these alternatives?
Yeah, so that's a great question, Captain. And so a lot of the challenges, or more of the technical oriented parties that are interested in the product is, water don't mix with oil. How can you make that possible? So emulsions have been, going on for almost 100 years. So your milk, your cosmetics, your shampoo is all emulsion. So that's basically what we're doing. We're infusing the water inside of the oil, where the water would not break from the emulsion, meaning that your engine components, your tanks, your piping will not touch the water, but the water will not touch those components. So as a process, we have to do an extra step to inform and educate the audience on that aspect. And then once we start to do a little more research and get more technical advice, from chemists and other technical parties, they realize that this is a product that really works. Okay. And the other item that's a little challenging, not too much, but it is, we have to make an extra step to sell the product, is the color is white. We can dye it. We have dyed green and blue. The U.S. Navy likes it blue, and the military likes it green. So we can dye different colors. So it's a little more of an extra step to create that opportunity to go to a sale. That's one of the major reasons we are focusing a lot on HYDRODIESEL Plus, which is transparent, the same as the color as the base fuel. And that we've seen that is a little easier approach to the end user and to the operator. But a good thing is that once the operator, end user, starts seeing the benefits We have done, trial runs, and they pilot programs. They run one engine on regular fuel and the other engine on hydrodiesel, and they just see the benefits within minutes, and that's what motivates them to say, well, this is great, and then we get to work with them. So those two are the main items, Captain, that we have to make an extra step to educate people on our product.
Thanks, Alex. There's another question actually for you. And this participant, Ricardo, is saying the concern might be, when will hydrodiesel be considered as a fully proven and acceptable technology with acceptable risks such as influence insurance premiums in the automotive, shipping, and air transportation sectors?
Yeah, so our product is ASTM D975 certified by SGS. Okay, we also have F76 certification by SGS as well. A hydrodiesel is the same as a fuel oil. It just has water infused inside. We are EPA registered in the U.S. to produce and sell hydrodiesel fuel into the off-road market at the moment. We're focusing a lot in the Gulf Coast region and the marine, agriculture, rail, and construction. Okay, and we are going to be obtaining our on-road registration as an extra step with the EPA. We're going to be doing that later in the year. And the U.S. is the only country that separates off-road, on-road due to tax purposes. And they direct red here in the U.S. off-road market. But in these other countries, on-road, off-road is a single market, and hydrodiesel can just go into both sectors. We do have product insurance. We do have liability insurance as well. That this insurance companies spend months doing due diligence and making sure to that our company or product can be insured, and we achieve that. So we're really excited about that. Another item to mention is the OEMs. So we have, consumers say, okay, what about my new Caterpillar? What about the warranty? Well, we have had conversations with Caterpillar, with Cummins, for example, and they gave us the fuel bulletin, and they said, well, if your fuel meets the ASTM D975 standards, we welcome alternative fuels, and we will warranty that engine for that end user. So that's what we're basing it off at the moment. We are having conversations with another large construction equipment company out of the UK that we're going to be conducting more tests. They're going to allocate a test cell for us, and then this is just for added value to give us more credibility in what we're doing. But we do have interest to work with universities here in Texas. We speaking with Texas A&M. At their director of ocean engineering. We're going to be doing some trials in Galveston area, and they're going to be doing white papers and lab studies. So all of these things we're going to be adding into Trillion, and more universities, more institutions in the U.S. and other countries, and all of this is going to be to give us more credibility and to push the product forward on a global basis.
That's really amazing.
And if I may, again, thank you, Sarita. I think we did discuss a long back, maybe things didn't turn out the way we wanted, but certainly as the University of Trinidad and Tobago, we do have operational engines in our workshop, and certainly we can create another test bed here for local stakeholders where they can actually visit the campus and see the engine run on this hydrodiesel and see the emission and other measurements on the engine.
Yes.
So we certainly need to move forward in that direction and have some action on that. Thank you, Alex, again for that input. I have a question if Raval is still here. Yeah. Yeah, hi Raval. Thank you again for your very nice presentation. In the presentation, and also I'm looking at the chat, we had some questions on incentives. I want to hear first-hand experience from you. Means, have you approached your flag state or say the region we are operating in, or charterer, or the port where your vessels operate for any discussion on these incentives?
We have had discussions with our charterers around maybe partnering on some of these projects. But, unfortunately, just in terms of the market conditions, the oil majors that we're working for right now, they are all in cost-cutting mode, as everyone would know. So, we haven't made much progress there, but they are very much open to working with us, at least on the operational front, to reduce fuel consumption and improve energy efficiency. I think that's probably where we've had the most success. There's been the active encouragement, if not drive, from the operators themselves to tell us to save as much energy as possible and reduce our fuel consumption. We, in terms of the flag state, our vessels are flagged locally with Trinidad, and then we have some vessels flagged with St. Vincent and the Grenadines. So I don't think we've received much support on that front in terms of incentives, but I don't really think there are any programs in place at the moment, at least on the maritime side. I know NGCC did a lot of work on the road transportation side in terms of encouraging people to adopt CNG technology via, subsidizing your retrofitting of your vehicle, as well as actually subsidizing the cost of the fuel as well, and actively trying to get gas stations to adopt CNG filling stations. So hopefully the NGC and NEC maybe look at probably trying to take a similar approach to the LNG and the alternative fuels route, trying to actively encourage that via investing in infrastructure, via actively encouraging operators to retrofit their vessels, etc. I think that would probably be the best approach, and they might probably be the best vehicle for driving that.
Yeah, thank you, Raval, for great input. I think, and this is where the the next steps Vivian will discuss before closing the convex. But I think we need to again reinitiate the Regional Industry Alliance topic as MTCC, where we can bring the operators, the fuel suppliers, the administrations, and anybody interested, even including ports. So where we can understand these, all of us understand the issues and challenges within, again, as I was saying yesterday, in our individual boundaries, but we need to come together, and maybe that regional industry alliance towards impacting or reducing the maritime emissions is something which we can provide as MTCC to the region. And I would say as MTCC for the Caribbean region, and more specifically the host institute, the National University as UTT. After hearing from PLIPDECO, I think I heard that you will be targeting maritime emissions in near future, especially while vessels are alongside. And we did some study for the 6 ports presented yesterday. So we are monitoring some traffic in and out of ports, and we will be very much interested. Again, if we are through the same industry alliance, if we are successfully able to create that, or you can approach us as MTCC or UTT for to be including when you're deciding on incentive schemes or measuring emissions from ships while they are alongside, and we'll be happy to collaborate on any such development. Thank you.
Thank you, Sujit. Sorry, Sarita, if I may jump in before you bring me in for closing remarks. I had a question for Keisha. I really enjoyed your presentation, and I was really happy to see, the steps that PLIPDECO was making in terms of decarbonization. And, as we would have seen, it's multi-pronged in the approach and the path to decarbonizing maritime operations. So we see where you're in collaboration with Pronto, and we know that digitalization is a huge part of the decarbonization of maritime operations. So I just wondered if it would possible if you can expand on that collaboration.
Well, we can't expand just yet. It's just ideas for us to do. It's something that we're looking into. We have not actively started the process or reaching out to Pronto as yet. But what we were doing research with their pilot project with Rotterdam Port, and the successes that they had there. We're also looking at Panama Canal and their just-in-time arrival systems that they have. So it's something that we're hoping to get into sometime soon, with that just-in-time arrival and the increased digitalization of our port operations. So when we do, we will give you feedback on how it's going with us.
Well, thank you. And I really hope that we will continue to be part of the conversations, because this is an area that the MTCC has taken on. It is an area of research also in terms of the campus at Maritime Studies. And it really is going to be, digitalization is a key to decarbonizing. And, you know, we've really seen the uptake of governments in digitalization because of the COVID-19. And we're hoping that it will, you know, the acceleration does not move into a decelerated mode when we start opening back up. So I think countries across the world have seen the benefits of embracing and expediting their digital agendas. And I'm happy to see that the ports are not being left behind, that they're thinking about it. And we do have some studies and some collaboration ongoing, not just with Pronto as well, but we also are collaborating, and Captain Singh in particular is part of a maritime informatics effort. And I would also invite him to reiterate some of the points that he would have made over the last 3 days in terms of digitalization.
Thank you, Vivian. I think that was an invitation for me to speak again, if I heard it correctly. Okay, sorry about that. Yes, I mean, maritime informatics is gaining a lot of visibility, I would say, and the whole concept is again on collaboration. I mean, philosophically, if I say that, I think what we all need is just trust each other. We are all collecting data, we are all making decisions, but somewhere we will achieve much more than what we are trying individually if we just trust and share some amount of data. And when we are looking at especially the port optimization, I mean, within the region, we can't achieve it alone. I mean, we have to, you know, share information with other regional ports, and what kind of information do we share, and the other actors within the port community. So there is a lot, and it's very interesting. I would say super interesting, and it has a lot of scope. I think 2 years back we did visit Flipdeco and Port of Spain to have some initial discussions, and once we again, I mean, coming back to the same industry alliance which I was trying to you know, promote a few minutes ago. I think now with our deliverables as MTCC, where we will be having, means this is our last main deliverable for this year. We'll have some time to concentrate, and we will be reaching out to all of you if we can have that platform as a regional industry alliance, and I think that would be a right platform to launch many of these initiatives which we have been speaking for so long. So surely, thank you, Vivian, and I'm looking forward for this, you know, super exciting, say, next 9 months.
Yes, indeed. Over the last, we have been focusing as the MTCC on capacity building over the last 6 months, I would say, with all the activities targeting the maritime administrations, our stakeholders, the CONFEX, our online training program. Incidentally, the online training program will be open for participants globally. So, you know, if you have an interest in training on board with maritime energy management, that will soon become available. We still have to work out the intellectual property rights with the IMO and the university, but, you know, that will be our to-do, and we will try to make it available to as wide an audience as possible. Sarita, am I free to move on to our next steps?
Yes, I just wanted to, before you get into that, to remind everyone to visit the virtual conference exhibition hall. We do have a number of our technology providers set up there. So we have Port Exchange, Sky Sails Marine, Man Energy Solutions, Trillion, Bergman Marine, as well as UTT, so you can explore what we are all about. So, you know, visit the exhibition hall and make use of the contact us buttons on each of those pages if you want to get in touch with these providers or have more one-on-one discussions. Feel free to make use of that contact us button. We may have missed a few things in between, but that doesn't prevent you from reaching out to us in future or to the companies directly, right? So Vivian, over to you at this point.
Okay, thank you. So I won't keep you back. I'm seeing where people are starting to log off already as they're moving towards their lunch. And as we traditionally try to do, to lock off earlier on our final day of conference. So I have 20 minutes to make sure that we continue that tradition of finishing earlier in our last day. So to wrap up our 3 days, you know, I want to first thank our all our presenters for truly insightful presentations, for sharing their experiences, their case studies. I would also like to thank our MTCC team members, particularly Michael and Tevin, who without them, we could not be such a success. They have been the persons reaching out to you, dealing with the underground logistics in the digital sphere and making things happen. So we wish to particularly thank both of you for really being such pillars of strength as we move forward in a virtual conference setting. In terms of closing, over the last 3 days, we have looked at governance issues, we've looked at technology issues, we've looked at operational issues. And I think underscoring all of that is collaboration, where we need to see the continued collaboration between government, industry, and academia across the region, within our own countries, and within our respective maritime administrations. In terms of the governance paradigm, as Rita and myself would have highlighted, as well as other presenters, we really need to ensure that whatever we're doing in the maritime front is feeding in to our larger initiatives in the national perspective and in the regional perspective. We do have regional challenges with respect to the implementation of MARPOL Annex 6, as has been highlighted even outside the region. A captain from Mexico was asking about, you know, the challenges of implementing MARPOL Annex 6. It always comes down to domestication and what resources we put towards the domestic implementation of these international conventions. We also recognize that the local and legal and institutional framework is fundamental to effective implementation of our international conventions. And in that respect, we recognize the challenges, and this has been highlighted by Jody in her presentation yesterday about the challenges even from a port state control perspective, with the limited implementation, even in the face of, you know, legal implementation, where you see ratification has taken place, but actual implementation is on average about 30% across the region. So we certainly have to perform better. But one of the things across all our workshops and conferences that has continued to be underscored is the need to raise the profile of the maritime agenda, both nationally and regionally. So how do we do that? We need to continue to coalesce our voices. We need to bring our voices together. So over the next 9 months, as Captain has indicated, we will be focusing on trying to raise the profile of the maritime agenda and decarbonization. These will be part of our ongoing initiatives towards promoting the work and progressing the agenda of the MTCCs. As you know, the MTCCs were all created for the purposes of assisting in decarbonization efforts of the maritime sector. So in terms of moving forward, what we really need to see is that coordination, and we will reach out to all of you to join our regional industry alliance as we try to progress this agenda. Because this agenda, for it to be progressed, we have to raise it nationally and we have to raise it regionally. We will also be outreaching to CARICOM through our partners across the Caribbean region. We will be reaching out to them to assist us in raising the profile of the agenda within the CARICOM framework. We've already been asking that it be featured in the COTED agenda. And we also have a colleague that recently said he would also raise it in the SEDEMA agenda. So we are trying to raise the profile and increase the conversations happening with respect to profiling the maritime sector with a view to bringing about the legislative changes and the policy changes required to progress the maritime agenda and the decarbonization initiative across the region. So there is strategy there. What we need is the backing. So we do have, and we continue to see the support for the MTCC and for the work that is being done. We will also be reaching out to our non-party stakeholders, and I'm very happy to see Captain Badaloo here representing by himself, and with respect to CARIB-MEPA. They will be instrumental as non-party stakeholders in being key implementers. All the studies are indicating that NGOs and non-party stakeholders are going to make a significant impact in implementation. They are expected to be the movers and shakers because they would not have the constraints of the governmental institutions. So because they are recognized as dynamic implementers, the Regional Industrial Alliance, we expect that they will be playing a key role towards enhanced implementation. Lastly, I would like to also raise the digitalization agenda. And while the governments are progressing towards this, recognize that the university is playing a key role, and we also need to ensure that Ministry of Trade with their digitalization agendas is compatible and interoperable with all the other governmental players. Because right now we continue, in spite of best efforts, we continue to have digitalization happening in pockets. And we need to have that being interoperable. We need to have the systems, and we need to have the legal frameworks legitimizing their interoperability. Because right now, one of the impediments for interoperation is because, I understand one, I'm not going to call the name, but one governmental framework, say by law, they need to use one particular system, which the ports don't currently use. And these are the things, and I've seen both ports use Navis, for example, and we've seen the power of Navis through one of our field trips to a port in Italy, where they use Navis to manage down to the truck scheduling and the off-takers and the containers. So we know the power of the systems that we have. In Trinidad in particular, we always buy the nice toys, but we don't necessarily invest in using the nice toys and the best toys. So, we need to change our paradigm where we're accessing and accessing the technology for the best practice, but failing to implement the best practice because we're not training for their optimized use. So these are some of the conversations that we will be continuing to progress in the coming 9 months. We also encourage you to look at our publications that, we really tried to reflect and consolidate the work that not just the MTCC, but the MTCC in collaboration with you, our key stakeholders, would have done between 2017 to 2020, because we believe it gives you a good snapshot of where we are now. So the publications are currently freely available, both on the UTT website and on our Convex page. So we'll also be coming to you with some further correspondence in terms of further publications that we'll be putting out. We continue to ask you to please reach out to us in terms of things that you believe that the MTCC should be focusing on. If you see that there is something that we may not have been actively participating in, to also reach out to us and ask us, if we would consider it. And as all things, we have identified that our agenda is likely to be donor-driven, but also recommend, there's that waka again, I'm sorry, I hope it's not too loud. I'm hoping that, that we are able to influence the donor agendas by ensuring that we write in our national and regional agendas our priorities. So, it's not just to say that the agendas are going to be set by funding and the donors, but the agendas need to also be informed. Oh, it's competing with me really badly, isn't it? So it's going to have to be informed by how we write those narratives on national and regional agendas. So I'm going to hand over to Captain Singh because I could barely hear myself.
Thank you, Vivian. You have covered most of it, if I would say, and certainly, as you were saying, that the lot of agendas will be donor driven, but it is our duty how we make the national and regional priorities to be featured in those agendas. And one thing there is again the constant feedback from all these stakeholders, and one I mean for that matter we have been discussing and we know, like for example the shipping which operates in this sector, we have a challenge in the age of specifically, and a lot of them maybe the capex doesn't support the retrofit of new technologies, right? Things like that. But then we have a very unique advantage also. And when I speak of this unique advantage, okay, there may be a ship which is 20 years old and say transiting between Trinidad and SVG, but this is the same ship which makes 60 calls or 70 calls in a year between two terminals, one in Trinidad and one in SVG. So we can bring any technology just specific, and the advantage is the size of shipping, right? These ships are not huge. They don't need 60,000 horsepower to run them. These are smaller ships. So even a hybrid solutions are suitable for them. So these are some kind of, I mean, for last 4 years, we have been engaged in a lot of research. And I think when I say next 9 months are going to be super exciting, is where with all this research, now we feel that with your support, we want some action. I think this is the action time now, which begins April onwards, and where we can make some informed decisions and say, okay, what is suitable for this place, what is suitable for ports, what is suitable for the ships of certain category. So all those things, I think we need to see that happening, and we cannot do that without again engaging or support from all of you. So I think that I would like to close on that high note of feeling that yes, we all are thinking outside of our own boundaries. It's not only about reducing emissions from my port, my ship, my fleet, or my country. It is all about how we see, okay, what contribution we can make in this bigger target of reducing the emissions, and how we fight this climate change. So thank you very much from my side, and thank you everyone for active participation and supporting us for the last 3 days. And feel free to reach out to any one of us. Thank you so much.
Thank you, Sukhjit, and thank you to all. And I think there's nothing left for me to do now but to declare this conference closed. So thank you all.